YouTube gets to be subject to the same start soon screen as everyone else, because they're not special. And I'm not sure if Social Stream Ninja is going to be able to find YouTube, because this is the old one. It's possible that I just need to find it again. Yeah, there it goes. Okay, cool. Now we're all up. All right, now I can get back to chat. What are you guys doing? Halo was a good game. I really did enjoy Halo quite a bit. So you've got 4. One of them is a different layout. It's a different flight stick, but it's the same stuff. And I think it's still Thrustmaster. I don't know where the base of it is. It's somewhere on the shelf that I'm looking at right now. But the Warthogs that I have, the ones that are going into the sim, we're going to take over and make into CAN bus devices. And burping. I literally only had a croissant to eat today, so I'm going to be burping lava, which is not fun. The Warthogs will speak CAN bus. It's got the sensor on it is an MLX 9033. The 9033 is just a magnetic sensor, and it's an SPI device. So we're going to talk to it using SPI, and the buttons are done with a shift register. It's 5 pins for a shift register. It's got a little connector in the base. That's actually a lot like this guy right here. It's one of these like old mouse connector types for the 5 pins. I'm going to add an axis to one of the joysticks. So there will be an analog axis on your thumb for up and down movement. So you can get the full 6 axes of freedom, because you have 4 in the 2 sticks, 5 in pedals, 6 will be the little thumb up and down. And the way that I do space sims, at least, is I use one stick as a pointer and the other one as sort of a shifter. And then the pedals rotate, and then the thumb will go up and down. And so those are all the axes. I'm more used to using the joystick to point at stuff in space than I am doing the whole tilt with the joystick thing like a real airplane. I don't do that. But there's always room for improvement, so maybe I can reconfigure it to be that way if I want. Man, I've got all these microcontrollers now that I did not need to buy. I have this guy just for getting used to SWDIO programming. Turns out Ben Gizmo was the key to all of this. I would have never, ever gotten it, but Ben Gizmo found in Platform.io, there was a whole block of code that actually enables the microcontroller to use its internal oscillator. And it's this big block. It was something out of Platformio, this thing right here, where you activate the internal oscillator by overriding system clock config, which I did not know, but this worked. And it got the microcontroller working. It turns out I didn't have to buy a singular other microcontroller. Now for the open force feedback thing, I don't think I'm going to spend the $30 to buy their board. I probably should, just to support them, but I've already bought a similar ST Micro test bed platform thing, and OpenFFB is whatever company they've paired with to make their hardware is shipping from Germany. So I could order from there and get it in 2 months, but I think I've just ordered something off of Amazon, and that way I can load up open force feedback and figure out what it is and how it works and stuff. Hopefully it's not too ruthless in its implementation. But yeah, I can't wait so I can sit in the car seat and have both hand on stick and stick, and then have the pedals at my feet. It'll be pretty cool. The ultimate masturbatorium for my man baby toys. It's a lot. It's like embarrassing to be building this thing. It is. Like I'm embarrassed. I'm embarrassed about this. This is so much. It's so much for like toys. But then again, I already had like all the accoutrement. I already had all the accoutrement. So it was an inevitability, but like, what do I do when I move? If I like move, I'm gonna have to either like break it down into sections or haul it out in one piece like it is. I don't know. It comes apart pretty easily. It's just silly. It's just this accessory that I always have now. I mean, it really was inevitable though. I mean, I built the entire steering wheel system for myself, and so I guess this is sort of the natural direction these things kind of go. But it's a lot. These beams are huge. They're an investment. I'll forever have a room in my house that just has this thing in it. We're gonna get a lot of streams out of that, though. I'm definitely gonna make it worth our while. Play some actual like simulator games and some stupid stuff that'll be just fun to play. Maybe some Euro Truck Simulator if I feel like it. Just kind of do a road trip in that thing, because I don't have the space to have a real car project. It's much more honorable to have a real car project. I could do YouTube videos on it, and then I would be famous, mildly famous within the car communities for the type of stuff that I do. But I don't have space for it, so here we are in sort of the dusty corner of Twitch, building with real car parts, but not building a real car or building a sim setup. I'll find it in my heart of hearts to be proud of this project at some point, because we are doing quite a bit of work on it, and I'm putting my best foot forward, but ultimately it's embarrassing. Oh yeah, we got to get this stuff out of here too, because we need to add wires to this thing. Where the USB port broke off, I'm gonna run 3 wires out, and those 3 wires are, unfortunately, we have to plug them into a virtual COM port, because this thing doesn't come through as a virtual COM port. I'm a little bit disappointed in ST Microelectronics, because they did such a good job porting the STM32 over to the Arduino, and we probably need to look up a couple examples of the STM32 with the ST Micro core, because they did all this work to port the core over to Arduino, and then they did not put the nice easy serial stuff on the SWDIO. They figured, you know, they give you like a COM port for USB on this, and that probably shows up as a virtual COM port, and that might be super easy to use with Arduino. That's probably what the case is. They didn't expect you to always be plugging into SWDIO, but because of the layout of this device, the fact that they use every single pin on the device, every single one, means that we only can plug in the SWDIO or USB, and so I am forced now to add an extra COM port, whereas I think they assume that you wouldn't permanently be using SWDIO to flash your chip. You'd be using something else, and then that something else would be how you would access the serial port more easily. But just because of the way that I code, I need that serial port. I need to be able to look at my variables and stuff and figure out what they do. Because I am not certain that the buttons on this are analog. I thought they were. I thought that's how you got velocity on this thing, was how hard you hit it. Hey, what's up, Velkin? What are you doing? Why are you in here? What are you doing here, Velkin? Why is he in here? Why is there a Rabaz moderator in my chat? What is happening? What am I missing? What's going on? This is unacceptable. What? Before stream starts proper, I have some bad news for me. Linux is now illegal in Brazil. What? Wait, what? What are you guys doing out there? What? That's because they can't track you. Brazil law. It is against Brazil law. I am this close to going to Linux. I really, really am. I promise you, I am this close. The only thing that's holding me back is Fusion 360. If Fusion 360 would get off their asses and become Linux compatible, I could see myself completely changing everything over to Linux, just because it runs so much better on bad hardware, and my hardware is going from being okay to bad as time goes on. It's all this age verification stuff. Wasn't that outed as some other kind of scheme by like Palantir or something? They say, oh, we're doing it to protect the children, which is always when you should get suspicious of somebody who's trying to protect children in that manner. We want to protect children from the evils of the internet, and so we need everybody to upload their government ID. You're up to something. It's like, it was in California, but then Brazil follows suit. Man, so many things California kind of trailblazes on. I'm waiting for the pendulum to swing in the other direction on all that. I mean, most people are already innately suspicious of these efforts, but Ban Linux OS. It's kind of ridiculous, huh? Yeah, they want to do that everywhere. So many people are going to switch to Linux because Linux doesn't give a shit what you're up to. And, nor should it. Nor should it. You're speaking to an older millennial who was forged by the fires of open internet. We were the experimental trailblazers on the whole. You could see anything. Everything is on the internet. You can access it, and it'll break your little brain. Sorry, kid. Your brain is now broken. You just saw somebody's head get sawed off. Like that was what the internet was like. And then you would, of course, find web pages that would have stuff like engineering information on it, and you knew it was good because it didn't have any flashy, fancy animated GIFs on it. Last I checked, Fusion worked on Linux if you ran it through botholes. There's a couple, I saw like a GitHub project on that too. I don't know how buggy that is. I'd have to kind of forge ahead on that one on my own and test it, see if it works or not. I'm not sure. That would be a really good incentive for me to flip over to Linux. Or I could just, boot off a USB key here and see if I can patch it all together properly. I mean, OBS, of course, is known to run pretty well on Linux, and Internet Browser, of course, works there too. For the extent that we use this computer as a PC, as a Windows PC, and there's not that much that's really very specific, what's up, Copper, to Windows that Linux can't do better. Terminal stuff, PuTTY, there's programs like it. Programming, obviously. Like the main thing is like my IDE is you guys telling me that I'm doing something dumb. That's provided no matter what. I'll always have a chat. I don't know about Social Stream Blade. That's like a Chromium thing, so I'd have to figure out another way to put you guys up on screen. But that's all accessible. I mean, I could do that through Node-RED if I need to. Although for YouTube, I don't know how that works because YouTube always has a different chat URL. And so I can't just like browser open it. I can figure that out. That's part of programming that I don't understand. I don't know about that stuff. Learning scripting is easier on Linux than it is on Windows. Interesting. Yes. I love how you have the exact statute too. Yeah, I mean, it's nobody can definitively tell me that Fusion works on Linux. They always say like, I heard it works on Linux, but then when you get down to the brass tacks, something is going to happen. So, and it'll be like, oh, nope, can't do that. Yeah, it's like, it's always just, there's an asterisk. But I could do it. I could probably do it. And then, the oh my God, the amount of relief, getting everything over and working on Linux, first of all, would clean up the computing environment massively. What I really should be doing for this stream in perpetuity, I should be spinning up virtual machines to do everything. Everything I do should be on virtual machines because we often will install some accursed driver or some weird thing that will like infect the computer. And I'm super cavalier about that because it's funny if the computer breaks. But like having a virtual machine, I mean, this is something that happened with programming the mutable instruments synthesizers. They had STM32s, much like we are using today. And we had to program those STM32s. We had to do it using the mutable instruments sort of toolpath. And the toolpath involved a console machine. I think it was Windows, but it was, a virtual machine that you start up in the console, and that's its own computer. And so if you need weird accursed drivers to get your STM, ST-Link running, your little USB dongle-y-do, then you can install the accursed drivers. They don't affect anything else. So it's actually a really good idea. It's a good idea, but it's something that I have not implemented or gotten used to. And also being able to go back to states within the virtual machine. There's just so many good things that can be said for that. VMs are cool. Yeah, and they're cool. I've been watching some of Varg Skeletor, Joel from Vinesauce. his Windows destructions, and they're really fun. It's basically Joel going into an old operating system and installing whatever until the operating system can no longer function. And things get real crusty. They get real crusty. At the very least, make weekly images of your install if you're downloading sketchy software. I'm not doing it often enough for that, maybe, but I mean, having things on like a really solid backup is probably pretty important. A lot of streaming setups, mine included, are a little bit of a house of cards. It's kind of a fragile thing, and when you mess it up, it's a panic situation. I've been through many of such, where you, I'll update OBS, and then it doesn't launch, and you're like, why did I click OK? Windows updates messing with OBS and audio drivers. Windows tends to just randomly select whatever audio output that it feels like having at the moment. And it's just a setting that you're gonna have to familiarize yourself with. All the audio setup stuff, because it just seems sometimes it'll just randomly choose things. Right now I'm pretty stable, but I also installed something called, what was it, Ear Trumpet or whatever? And that means that I have two audio things, and one of them is incredibly cursed. And I probably didn't need to install this. It's when I was experimenting with mixers and stuff. But look at this. Now I've got every single audio source thanks to Ear Trumpet. But they're all just at 100 because I don't touch this stuff. Because I moved it all to a physical mixer, and now the mixer has all the configurations for the lapel microphone. Because you need to do some tricky stuff with a compressor and an EQ in order to get the lapel mic to actually sound like a real microphone, instead of picking up things like me crinkling two beard hairs together. That was audible with the lapel mic and none of the settings set up. So having it on a physical mixer means that's what I have. And if I have to go on someone else's show or anything like that, I can bring the mixer with me. And then that just has all of my audio. So if you want the bother sound, that's how you get it, right? I have pandemic hit, and obviously hundreds of miles away from all of my peers, coupled with the fact that none of us are particularly super successful. Uo's Lab did really well to do a bunch of other variety stuff and get all kinds of VTubers on, backing him, getting him hundreds of viewers. It'd be awesome if I could somehow manage that. I don't know how I'd do it in my own way. I have to figure that out. But yeah, I don't have hundreds of thousands of viewers, or thousands, or even hundreds, or even tens. If I did, maybe I'd be flying out and saying hi to some other of my peers. But that doesn't really happen. Anyway, just in case, I do happen to have a physical mixer with all my settings on it, so. Rocket-fueled power router. That's not even difficult. That's like an easy one. All I need to do is get one of those little drone motors that I have, hook it up to the output of a rocket engine, and then it would spin itself into oblivion. Now we're doing microcontroller-y stuff today. We're gonna do a little bit of programming on this thing. I'm gonna add some wires to it, so we'll start off with soldering, because I need to put something where the USB port was once. I could probably configure this thing to plug directly into USB, but we're going to access whatever UART is involved with the USB port on its pins, and then we will get that to print serial, and then I can finally look at variables like an analog read of the buttons. We know this thing works. I can power up all the LEDs, and I know which one is which because I made a routine that would go through them and light them up. I know I have to separate my own prowess with Twitch's prowess so that I can be a little bit disingenuous and have more exciting content. Where I say, hey, can I brew beer in a toilet? And like, I know I can brew beer in a toilet. I'm an engineer. I know that ceramic is pretty easily sterilable, so I can really bleach down a toilet and make a mash in there. I don't want to do that. I don't want to do that. Doesn't sound fun. Analog read of pad 1, and then I tried to serial print and it didn't work. I'm gonna get the music out of here. Let's just start. I mean, nobody's coming today anyway. Nobody is here to help us. We're all on our own out here. Actually, no, we got 31 viewers. That's pretty good, man. And YouTube viewers have been going up too. So I'm actually pretty excited. It just clicked for me, no Gabe Cube, because it's Linux. But how long do you think that law is really gonna, like, I mean, somebody's got to push back against this stuff, right? We're sort of on the precipice of these newfangled, likely from religious interests lobbying, identity laws for the internet. They want everybody to be identified and know that you're of age and stuff like that. And they push it as that, but then it like, somebody's pushing for this, and it shouldn't be. Anonymity on the internet is kind of an important thing. Been trying to push back for 6 months. Yeah, and it's like, by the time you find out about these things, like they're already, it's like, oh, by the way, this is in legislation. We're going to sign it in like a week. And you're like, whoa, wait a minute. Who's doing this? Who's paying you to do this stupid crap? I don't know, man. I feel like the Gabe Cube will still be available in Brazil. That's a huge market, you know? I don't know. Maybe there will be like a government Linux. And then you can just throw your own on there. It just seems really stupid. It seems really dumb. I don't know. We're cursed to have to deal with these mouth breathers. All right, I'm gonna start up here. Start the stream. Let's get the music. Do a little thing. Just gonna get Squib tonight. Where's get Squim? Yoink, and pause, and then I get to go to this camera and I get to hit this button, and stream is started. I know the border between actually streaming and stream starts soon is gray. There's not a lot defining one state or the other, but the intro is when we just hang out and talk about whatever, and then the stream is when I'm actually working on the project at hand. A lot of streamers I've seen, they've got a countdown timer, and they'll have like a splash screen up. I could do that. I could do that easily. Hey, what's up, Madamu? Welcome to YouTube. I can do that. I can easily do that. It's just, I would rather just have the regular cameras going and make sure that they're working. You know, do one of these and go, how are all my systems doing? We're good? Everybody's running? How's my butt? Does my butt look okay? We'll just hang that thing out there. There we go. Perfect. We're going to get so many viewers today. Oh yeah, you guys, we're going to get all the viewers. Anyway, yeah, so I like to make sure that all my systems are good, because these Logitech cameras kind of forget their settings and become obnoxious. So that's why we have the cameras going during intro, and it's, you know, I'll set stuff up, I'll plug things in, I'll turn on lights, all that stuff. So that's really the purpose of my sort of intro-y screen. Anyway, what are we doing today? Well, okay, so I got this MIDI pad, and we've been working on it for a little bit. We discovered that this MIDI pad is using an STM32. And my experience with STM32s are mainly through, what's up, Lines and Squares? Mainly through synthesizer programming. The modular synthesizer project has had me experiencing many different programming environments. These little STM32s are quite ridiculously powerful. This thing is like 10 years old, and yet it's 70 megahertz, like with 4 cores. It has no business to be this powerful, but a lot of people love using them for pretty power hungry projects, like creating waveforms and stuff like that. Like, incredible. So I bought a couple test boards, more than I'd like to admit. I have more of these things now that I think I'm ever going to use, and they're already obsolete. I'm just using them because we found one inside of this device. I bought this MIDI pad a long time ago in order to do simulator stuff, space simulator. I had this thing all set up for Star Citizen so I could turn on the lights in the spaceship and stuff. And then Star Citizen turned out to be more of a boondoggle where, oh, you personally are the person in space. And it was like, man, you know, Star Citizen started out, and when I really bought into it, saying, you're the spaceship. You're a spaceship and you're doing spaceship stuff and you're flying around in space. And we're going to have a modern space simulator. And then it's like, well, but now you can go to the store and get a soda and dress up your doll. And it's like, come on, man. So they've kind of gotten away from that. Not to mention the fact that like, it seems to be in an ever increasing development hell. It looked like it was pretty promising as becoming a space simulator for a bit. But given the director's reputation of not releasing games and having Microsoft come in and go, hey, we bought your company, release this game, and then finally release it. Yeah, I don't know if we're going to see Star Citizen anytime soon. I hope, because their demo is pretty extensive and does great stuff. But I'm not holding my breath. Anyway, the point is, I bought this so many years ago for Star Citizen when it was a simulator, and you could use these as different functions. This is a MIDI pad. This is designed to plug into your computer with a USB port and do MIDI stuff. MIDI is it's a little bit weird, but basically you could hook this up to like what's the program? Ableton. You could hook this up to Ableton and have it control like, you know, drums and actually like play stuff and all that. Well, it sat in a bin for many, many years because that's essentially what Star Citizen was doing, is sitting in a bin for many, many years. And I finally decided, well, I decided to put pressure on my brother, my dear beloved brother, may he rest in peace. He's still alive. I just hope he gets good sleep. He gave me an entire whole ass BMW car seat. And the whole ass BMW car seat means that all of this weird simulator crap that I own can finally go into one thing where you can sit down and use it. So that's pretty cool. I'm still trying to figure out armrests. I was going to get the same armrests as my, you have activated my Start Citizen trap card. He's going to send me to the Shadow Realm. This setup, I'm still kind of figuring out how I want to do the arms. I was going to get the same arms that are in my office chair, but apparently the one set of them that are for sale on eBay they want like $200 for them, and I'm not going to pay that. I'm not going to pay that much for armchair arms, ones that are damaged, you know? The cool thing about the chair that I have is that you can adjust them up and down and in all other directions, and you can also just push them completely out of the way. And so I thought that would have been really good for the simulator setup, because then you could push the one out of the way, sit down, and then bring the arm in just to support your elbow, whereas you'd have all of the other stuff, the controls, mounted on basically side rails that I haven't put in yet because I've got to kind of finalize the position of this stuff. So anyway, the point is we are working towards having all of that simulator stuff working together and in a system that I can kind of reconfigure. And my thoughts on it, given the direction that everything else is heading, I need to get more comfortable with the CAN bus. CAN bus is a means of, it's a differential signal that's used in a lot of industrial purposes. Lately, people have been using it on their 3D printers so that they can have fewer wires going to the hot end. You basically have power and CAN bus, and that's all you have going to the hot end. And then you can have all your switches and motors and nozzles and whatnots. Even an accelerometer that's reporting back. That's how fast it is, 500 kilobits per second. So OpenFFB board, the project, uses CAN bus. And so I too would like to use CAN bus. I think, all things being forgiving, this is just literally me. This is like the biggest ass pull. You know, I haven't put any numbers to this. I think it'll be fast enough that if we make all of our accessories CAN bus, and then we make our HID devices and our outputs CAN bus, I can then have a complicated set of controls with a Raspberry Pi sitting as a man in the middle, relaying instructions to HID devices, to the feedback board, and to other physical things. We discovered, in the parts that my brother gave me, that this thing also speaks 500 kbps CAN bus, and it works like two separate devices. One of them looks for CAN bus signals that the transmission's putting out to tell it what gear it's in or if it's in park, and it will light up what it's doing. The other device outputs button presses from the 4 positions of this thing, and when it sees the transmission is in drive, it allows you to kick it over and do the plus minus. What am I going to do with this in a simulator setup? I don't know. These things retail for like $100. You can get, I would suggest getting the Volvo one of these, because the Volvo one is a lot more comfortable. It's this little nub. I don't think it has lights in it. Well, actually it might have lights in it. There's also backlighting too that I want to be able to activate on these things. So anyway, if we do the same thing with this, basically what this will do is give me button press statuses, encoder thingies, and analog thingies. So it'll have a couple different outputs, and then I can send back signals on whether or not to light up the lights on it. So I can have things that'll activate and toggle, and even if I want to backlight, I could have a dim backlight on all of these so that I can see what they are, even though they're blacked out. So I guess if I put like a little text on there, I wouldn't be able to. Anyway, point is, if I have things that are toggles, if I have things that are activated. The other thing is we did a full reverse engineer on this device, so we know what all the pinouts are. We know everything that this does. I'm not sure if these buttons are analog or not. With music stuff, you have sort of a velocity, because hitting the button like this and hitting the button like this should make different noises. It should be louder than the other typically. I think that still exists in here, but I'm not certain about it. I tried to get the lights to light up in a particular way when the button was pressed harder or softer, but because I'm not familiar with the STM32 core, I don't know if that worked. So we need to have a serial print on this thing. And the best way, the easiest way to have a serial print is to hook up a UART. I forget what the acronym, what does UART mean again? I forgot it. Let me get my little programmer here. The way that Arduino, what's that? I once spent too much time debugging why my CAN bus did nothing. It turned out I was using a CANT bus. Yeah, we'll be here all evening, folks. All right, yeah, so the thing about the STM32 is that it really wasn't meant to be an Arduino device. It wasn't really meant to be an Arduino device. They kind of are more hardcore microcontrollers where you find them in so many different things. This is probably using some accursed weirdo microcontroller. I don't know what it is, but the STM32s you find all across like music devices and things like that. You'll find them in stuff, not even expecting it. Never apologize. We appreciate you for who you are, even though I may downplay the jokes. I'm the one making the jokes here. Anyway, point is, we found an STM32 in this device. STM32's not really meant as Arduinos. ST Microelectronics was kind enough to come up with an Arduino core, and we installed a very old version of that. With that, certain things don't kind of mesh with the Arduino, and one of them is with the SWDIO programmer, it does not show up as a virtual COM port, and so we can't really use this as a serial output device. I wish we could. It would be, it's all within the realm of possibility. We could probably alter some code somewhere and make this thing into a device that speaks serial to the Arduino. I mean, for the teensy family of microcontrollers do it, anybody could, The teensies have like the same deal, but they're using a Freescale semiconductor chip, but they'll output using, here's one. Nope, that's an RP2040. That's, okay, well, anyway, I've got teensies up here. The teensy will do that. It'll do a serial print from its Freescale semi weirdo bootloader, right? It's got a separate program that bootloads the code in via USB. Just as easily, we could probably have the ST micros using the SWDIO programmer, but I guess they don't expect us to necessarily use that. They want us to use the USB port that just speaks directly to the chip. The reason that they do that, by the way, the reason we have USB support like that on these microcontrollers these days is because you used to need something called an FTDI chip. And what that does is, instead of just your COM port directly connecting to an external device, we did away with COM ports, and now we have USB ports. So what this chip does is it's an ASIC that turns your USB into a virtual COM port. So it's mostly drivers doing the talking, but FTDI somehow got themselves some type of a patent, and so these chips were like $15 a pop. And all these microcontrollers are like, well, all these microcontroller companies are like, well, we don't want to spend an extra $15 a board making sure that we've got USB compatibility, but all the consumers said, hey, screw you, we're not going to buy a $300 programming device, you know, the non-knockoff version of the ST-Link. This is definitively a knockoff. I don't know why they have the ST logo on it. They should really be sued for putting the ST logo on this thing, because this cost me a few dollars. But the real equivalent of this thing is like $100. I'm not going to spend $100 to program some shit. And my sentiment is shared across the entire hobby to the degree where they've put USB compatibility in the actual microcontroller so you can throw a bootloader onto it. It's become kind of an important facet of this whole microcontroller thing, and it makes it much more accessible for everybody when you don't need a you know, university budget in order to throw some code onto a thing. Having the logo makes it a true knockoff, not just a random brand alternative. I guess that's true. These things are notorious for having a wrong pinout printed on it. That's why I have a sticker over the pinout that's printed on this side. Other side is correct. So that's the correct pinout. It's a mad world. Mad world. Okay, so anyway, if we get TXRX and ground on this, then we can just do serial prints directly from the chip, and I can see what my code is doing. Alternative ways to do this would be using a screen, or using an LED to do like a bit bang serial, or, you know, some other way to display what's going on from the microcontroller. I prefer to have a serial line, and I think it'll be easier. I think it'll be easier if we just can print out text that looks good. So let's get this thing open and let's solder some wires onto it, and we can just have them poke out of the open USB port. And then we can start messing with the code. I set up all my software so that I've got all the pins in there, and I put all the pins in a table so that we can call them up easily and iterate through. Yes, sir, yes, sir. Other than that, didn't get a lot done. It's a bit. I got a bit done. I didn't get as much as I would have liked. Not as much as I would have liked, but this stuff is steaming ahead and it's starting to get really interesting. So I kind of held off on it a little bit so that you guys could get the experience of some of the actual progress being made. Once this is to a state where it's sending out CAN bus signals of our own, that builds up sort of the framework of what the other device's software is going to look like. And then we can hook this thing up to our main CAN bus, and we can evaluate if the Raspberry Pi with Node-RED is going to be fast enough. What I want is an interface that has all of the buttons and knobs and levers and switches on one side, and then on the other side I have my USB devices, etc. So I will be able to turn on lights using, you know, like I could hit the parking brake button here and I could have a light turn on if I want. That's the idea anyway. It should start coming together. We'll have to see whether or not it's slow. And I think the way to keep that fast is if I have button states. So each device sees the states of all of their buttons, and when something changes, it sends out a CAN bus signal. I think that's the way it's got to work. I don't know about negotiating whether or not there's activity on the bus. If I use these, that'll free up the microcontroller. This one doesn't need that. The STM32 is pretty fast. I think it could probably handle listening to the whole bus, because I could just make one of the threads listen to the bus with one of these TXRX guys. But the rest of my devices should probably use these, which have slightly different code. It needs to be initialized via SPI, but then this thing listens to all the CAN bus signals, and then if it needs to send an output, you buffer it into this thing, and it'll find a time when it can speak to everybody. So I think that'll be a good system for some of the other devices. It's a lot though. I mean, it's like a whole crystal and everything that you gotta. Anyway, all right, we're over here, and I'm going to solder to. Oh, come on. That's right. USB lines are on the other side of the board. All right, I got to take the whole thing apart again. That's annoying. I want to put like a couple wires on the other side of the board, and unfortunately they sandwiched the USB plug between the front face and everybody else. So it's not too much. It's not too much effort. It's just a little bit of extra effort. Really what I should do is just put the CAN bus stuff in there already. I'm probably just going to solder this board in here, and then, I don't know, have like a 4-pin plug as the output or something. I don't know what else. What can I mean, I'm not gonna. I don't want to put a USB port there because then I'll like accidentally plug it into USB. Although then again, I think the ST Micro could probably determine if it's plugged into a USB port or not. But I don't know. Yeah, we're just going to do a quick little wiring thing in and out. All this to get a serial port, huh? What else has been going on? Other than crazy identity laws. Like banning an operating system in a country, especially Linux, is just going to make them use Linux harder. You know, they're just going to do it more. It's not going to stop them. They won't go, oh shucks, I guess we won't use Linux. It's, no, I'm going to use Linux more just to spite you. Because like, that's the kind of person you're talking about in the first place. Oh, by the way, I got this thing to finally come off of the steering, whatever it is, the steering column. It turns out, I'm dumb. You can see all this damage up here. The screw, you just intuit by the placement of the screw and the radius of this thing that it actually interferes with the steering column. You probably can't see it from this far away, but that little output shaft, the little splined shaft, actually has a notch cut around it. And the notch, what's up, Bothan? The notch is captured by this. I simply loosened this and left the bolt in and then used a pickle fork on it. You can see all the damage. I used a pickle fork on it to try to get it off of that steering column. Much to the chagrin of the aluminum here, I had thought that the steering column had a steel shaft on the bearing there, and then this was aluminum, and so the dissimilar metals did their thing and welded themselves to each other semi-permanently. I'm sitting here hammering a pickle fork in there. I'm using screwdrivers that I'm bending, and then I went to finally put a piece of metal in here and then screw this in from this side, which would force it apart. And I go, man, why is this thing so hard to unscrew? It's putting up a lot of fight. And then I pushed on this and the screw became loose. Oh no. Took this thing out. This thing dropped off. It just dropped off. I feel like such a clown. I feel like such a clown, chat. Yeah, this apparently captured the whole thing. I thought it was stuck. So we finally have access to that. I can start thinking about how I'm going to mount that 20-pound motor onto the thing. And I don't know what I'm going to use for the coupler. It would be nice if I could use this stuff. If I drill out these, I could attach this to the front of the motor. The more you know, yeah. What I'm concerned with is that what this connects to moves like this. It moves a little bit like that. And so with that shaft moving like this, I have a motor that I need to match that movement. And I think what I can do is use the original, like the Scandinavian mount that I have that allows this thing to tilt on the desk. That's what it's really for. It's got a pivot up here, and then that moves back and forth. If I can do that without it becoming wobbly, that'll be good. But the other way, I mean, I would need something that stretches. Like the original Mercedes one actually has like a spline shaft that goes in here, and this whole assembly can expand with the wheel moving around, with the steering column adjustment. I can't really do that. This is too long. It's too much. It'll stick way out and it'll be really weird. So I don't know what I'm gonna do. I'm gonna delete this part. The rubber, of course, can go. And then maybe this can attach to the motor, and then the U-joint will allow it to be out of alignment a little bit. And then I think that the servo mount may allow it to adjust. I don't know though, because that would be a bolt sliding in a hole, and I don't like that. Maybe if I could put thrust bearings on the two sides and pinch those in, and so then that's a bearing pivot. And then on the bottom ones, maybe I could just put pegs and then the pegs move back. Maybe that's the way that it'll go. But then the weight of a 20-pound motor is going to be on this, so that'll be a little weird. Hopefully the motors can handle it. We'll have to figure it out. I'm going to jump into the mechanicals like cavalier and just get it done. All right, I need 3 wires. I need 3 volunteers. Can I steal wires from something that we just took apart? I don't think so. No, I want really lightweight wires. I think I want these because then they won't tear off of the pads as easily. These pads already had a USB plug tear from them. It already had, it's already been separated from a USB plug. And so I'm doubting the interface is going to hold up to strong wires. So let's get a red. Actually, no, we don't need red. We just need 2 lines. One is a TX and the other is an RX. We'll figure out which ones they are on the fly. And then, do I need to separate it from all the USB stuff? I don't think I do. I don't think I do. Yeah, the more you know. Do. Did you try to hammer it with a screwdriver handle since you already tried to pry with them? Yes. I tried to hammer a screwdriver handle into this. You can see it's all effed up. I'm gonna have to take a file and maybe get some of these edges off of it because like here's where the pickle fork really dug into the aluminum. I was wrenching on this thing. It should not have been interfaced at all. And I was starting to think about like what kind of special tool could I make that would push on this, but like you can't get in there because of the U-joint. And then for the U-joint, they relied on the softness of aluminum. I always rely on the softness of aluminum. They relied on the softness of aluminum in order to install the U-joint components. So they actually pushed in its stool. No, they pushed in a little tab of aluminum in order to hold this stuff together. So I couldn't take this out in order to access what I thought was dissimilar welded metals in here. But like, look at that. The bolt interferes. That's what I was fighting. I wonder if there's damage on the bolt. Now the bolt held up to my shenanigans pretty well. It being harder than aluminum, I suppose. I think it's not a stretch bolt. It looks like a stretch bolt, but I don't think it's a stretch bolt. Yeah, it might be. Actually, that right there. Yeah, this might be a stretch bolt. Anyway, stupid. It was just a matter of removing this fastener in order to get this thing to separate. This is in really good shape, and I didn't need to buy the entire other steering column part. This is the type of stuff that you regret when you do development like this. The path forward is never as efficient as it could be, and you must live with yourself. Okay, so what I'm going to do is just put a wire on D+, D- and ground, and because we know the layout of this thing, because I reverse engineered the whole thing, we know what pins that goes to, so I'll get the normal size iron tip. Yeah, the more you know. I mean, if we had figured out the microcontroller stuff more easily and sooner, if I had just streamed it so that Ben Gizmo could tell me what the right answer was, then I wouldn't have bought so many ST Micro development boards. I'm going to have like 4 of these things. 2 with this micro, 1 with a slightly more powerful one, and then 1 with a broadly more powerful one that I think open force feedback can use. So there's the port. Let's get that on camera. Move all of my accoutrements here so that I can actually get to my soldering iron. Why do these pens keep coming out? I keep finding these pens everywhere. What does it mean? It's a conspiracy. Need more carbon monoxide so that I can be suspicious of people doing things. No, I think I had to fill out some forms or something. All right, soldering. This is my comfort zone. You can see here very simply how the USB port is interfacing with everybody. We've got some kind of either a static arresting device or a Zener diode that's configured in order to limit the amount of voltage that can get into this thing. I don't know what the voltage limit is. We haven't tested this at all, and I don't know what component it really is. I would think that it would be something along the lines of static mitigation, but then we have an LM1117, which is even more in the realm of musical devices. We see the LM1117 almost universally as the voltage regulator in these modular synthesizers. They sort of a different philosophy of engineering into these things. It's kind of interesting. What is over 9,000? I had my nephew ask me how many followers I have, and I told him it's over 9,000. Oh, it's 10,895. Man, we're almost at 11,000. That's awesome. Hey, pretty cool. Thank you, everybody. Wonder how many of those are dead. People who followed and then they died. Okay, so the USB ripped out of this thing. That's fine. We're going to use it for CAN bus, and what I'll do is I will solder. I don't want to solder wires directly to it and have them go straight out of the board, but I think that's what's going to have to happen. Maybe I could I don't really have like a zip tie. Maybe I can just take a little piece of wire and put it around those two holes. Those are the anchor holes for the USB plug. Anchor holes for the USB plug are super important because you have basically a 10,000-pound gorilla plugging in and unplugging your devices. The consumer can never be relied on to be gentle to your electronics. And so when you build stuff like this, you need to make sure that the ports are extremely robust. And when assembling these things, why is there hair everywhere? That's a beard hair. That's definitely a beard hair. Beard hair, dog hair. There's even still other hairs in the, geez. This is what happens when I don't solder stuff for a while. The hair moves in. But yeah, never rely on your consumer to be gentle to your devices. And with USBs all across the board, people have been ripping them out for centuries. The USB Mini was supposed to be a little stronger, and especially this one because it's got these little bolsters on it. But as I say, never rely on the consumer, but also never rely on the manufacturer to properly heat up and solder your giant ground pads, because that's where it ripped off. These were victims. Those were properly soldered because you could see it ripped all the way down to the silicon board. These were not properly soldered, possibly holding it in heat just a little bit longer, which is anathema to the manufacturer because time is money, kid. So it ended up sacrificing my poor USB slot. Anywho, yeah, look at that. There's still pieces of pad on there. When you design these things, obviously cater for the little pins on that, because that's gonna massively increase the strength. And then maybe if you've got the ability to put a via on these. If you put a via on those that's large enough, goes to the other side of the board, it'll act something like a rivet when everything solders over. And especially if you can get the solder in there as like a rivet material, it'll hold really, really well. This does not have a heat relief. I am heating up the whole board when I try to solder to these pins. Holy shit. I'm gonna have to get the big tip on that because this one just can't cut it in this dog world. It's dog eat dog. But I don't wanna dogs eating dogs. It's weird, you know. It's like there's more than one way to skin a cat, you sick freak. Why are you out here skinning cats? What the hell's your problem? Big tip. Here's a tip, kid. All right, hold on. I gotta get in there with a little bit of my solder because their solder is old. Old solder crystallizes a little bit, and this will bring in a little bit of flux too, which, you know, if you've ever watched an electronics channel, you know, flux insulates from oxidation. It'll hold the heat in. Everybody say it. It's the mantra. But bringing in this solder also makes it a little bit leady. They're probably using lead-free on this, which is a good thing. Lead-free is a good thing. Everybody makes it out to be a bad thing. Because, I don't know, even like in electronics, I can't believe that people are not down with changes that positively affect the health of the users. This is partially leaded because I was going to order lead-free solder, just to show that it's fine. It's fine. You turn your iron up a little bit, and then you can work with it just like regular solder. It's really not that different. It's not that frustrating. The people who complain are usually the old people in electronics, and they don't take to change very easily, even though electronics is change. Like, this whole hobby is technology. It's ever increasing, ever changing. I don't understand why these people complain so much about leaded solder. Sure, it's not as pretty. It doesn't work as cleanly, but it still carries electricity. And if you turn up your iron and use a little bit of flux, you are fine. It does fine. And you're not fucking breathing lead fumes. You know? Like, I don't want to get cancer. Having a lot of trouble on this pin, and it's just because if you look on the thermals, you can see I'm heating up that entire side of the board. The whole board is being heated by my efforts to solder because they didn't put a strain relief, or sorry, a heat relief pad on that pad of the component. It's literally just a checkbox, and it'll do one of these little radiuses around the pad with the little cross that connects you. They really needed to do it for these two. It's partially, well, no, those seem soldered okay. Those seem like they soldered all right, but it would be one way that this thing would not solder properly. But it was, shockingly. This wire is all up in my way, and then my camera's loose. Why is my camera loose? There we go. I wonder if those O-rings on the camera mount would have been something to keep if they would actually, because I found them to make it hard to adjust. And so I removed them, and I just rely on aluminum against aluminum in order to hold the camera in place. It's got this double ball mount that's meant for like putting screens on camera equipment. This just is not flowing. Where is my... Getting mad, I'm getting mad. Push comes to shove, I use the giant soldering iron tip, but that's really inelegant. Might have to. Yeah, this is too frustrating. Okay, well, so be it. Do we go for the nuclear option? I think I go one step below the nuclear option, which is the high wattage, same size tip. It just has a bigger heating element near it. It can deposit heat faster. Whoa, that was weird. Ever increasing. Reaching the groovy would throw it across the room point. And well beyond. I have been credited for having an incredible amount of patience on this channel. Don't get mad, get everything. Well, that, like, I guess that worked. It's a little, I'm not going to adjust it because at this point, it's what it's. Yeah, happy St. Patty's. I don't have any, the only green thing here is the circuit board. I don't know, I didn't prepare. I didn't prepare at all. I barely even knew that it was St. Patty's. There goes the dog. Dog's having a day of it. She's just been barking at everything, man. All right, so I'm pre-tinning the wire so that I don't have to spend too long soldering it, and it goes in cleaner. And then we're just gonna try to, well, should I add a little solder to that? I don't think I need to. I think we keep a minimal amount of solder down there. And then I gotta be careful because this tip brings with it a lot of heat. I mean, we are a temperature controlled iron. That's too far to the side. But this'll, see, this flows it over like immediately. It's really too big of a tip to be doing this, but I'm gonna do it anyway. I guess when I lash it down with a wire, I can come in and clean that up a little bit. The real cool way to do this is if you dip the tip of the wire in solder paste, and then when you solder it, it has exactly the amount of solder needed. It's a really cool way to tin them, but my solder paste is so old that I don't think it's, I think it's probably solidified at this point. You gotta keep solder paste in like the refrigerator. It's really weird. Let's get that flat. Excuse me. Actually. Hello? There we go. There it is. 3 little wires. Take a cut of one and put it across them to keep them from flexing at the metal. Do a longer cut. Like that. Actually, I think I partially cut. I'm going to do another cut. Another cut, another cut. Tweezers. My fingies are too big. I mean, a little dollop of hot glue would also do the same thing. Probably better, but we'll use some of the wire. Probably be better to use a silicon wire. If these things unintentionally heat up, this could be a means by which to short all of them together by accident. But I think we'll just live with it. I think we'll just live with it. The world can't control my hands today. Ta-da. I'm actually kind of surprised that that worked at all. Okay, it's not clean, but it is done. So we have our serial output available to the UART on these lines. And it doesn't look like I bridged contact at all. That one's coming in at kind of a weird angle. But I'm not really gonna pressure this any. I think it's fine the way it is, unless that's making contact. I don't think it is. I don't know. It's hard to see. No, I don't think it is. Okay. All right, so now in the future, I'm going to be routing these to this little CAN bus guy. This thing takes in a TX and an RX, and it outputs CAN bus, and I'll have to find some sample code for it for the Arduino. But for now, I'm not going to put this in because that adds a layer of complexity to what we're doing. We're instead going to plug it into the FTDI so that it can be a virtual COM port so that my Arduino IDE can output the serial signals that we're going to give it. That'll give me an insight into what that microcontroller is seeing and doing, and then we'll be able to get it working in that sense. And in the future, I'll add CAN bus to that. You know, I guess maybe I could have programmed one of these with the core and then taken a look at what the signals were, or I could have put the pad on the oscilloscope. For me, this is the easiest way, and it's kind of a unique way, so I'm doing it like this. All right, get my tools back to where they go because I don't want to lose anything. Oh my God, everything is out. Okay, and then put this back together because that was the original intent, was to see it working in situ to see what kind of signals we had to convert over to CAN signals. What did you do with my screwdriver? I know you're up to no good. Okay, it's right here. It's on the thing. Yeah, I see you, chat. Got all that just to do 3 wires. All that for 3 wires. My whole kingdom. $2. Now the trick with this is to find the groove that's already in these posts, because these posts are molded without threads, and then they rely on the screw in order to give it those threads. And so if you don't find the original threads, you can end up thrashing your plastic posts to the point where they don't hold on to the screw anymore. So it is in your interests to sort of just very gently rest the screw on the post and go forward until it finds its own groove, or go backwards until you feel it click. So I can go backwards here and then I'll feel clunk. There's a little click over where it falls off of the one ramp and you can get it to start in its own. And if you do that, then you can do things like I do, where you routinely screw up and have to take the whole thing apart again and again without ruining all of your plastic posts. Is it a bad idea to go all the way back in this, put it all back together, and then yes, yeah, probably, but I'm going to do it anyway. I probably don't need to put all the screws back in. Probably better not to. What I'm wondering about this thing is, with the limited number of pins that they got the particular ST microcontroller that had 64 output pins. There's a version of it that has 100. They didn't use the 100 pin. They used the 64 pin. They didn't even put a crystal on it. They got it to speak USB, MIDI, but then they have a matrix for some of the buttons. For these 8 buttons, these are on a matrix. These go directly into the microcontroller. So what's going on? Imagine a chat-controlled robot arm that can steal your tools. The way that I die, the way that O'Bother meets his maker, is I will one day buy a second-hand industrial robot arm, and it will inevitably crush my fleshy human body. That's what's going to happen to me. That's how I die. Hopefully it's all just me and not some other YouTuber or Twitch streamer there. Hopefully it's all on me. So yeah, Bother, he programmed a robot arm a little weird and it crushed him. We don't have to do those screws, although having them here means that I'll probably lose them, but just put them over there. Got to put all this stuff back together. And then what I'll do is I'll put a header into the programmer and try to get that going. Now, in the Arduino, I told it to serial print the input from P1. So when I turn this thing on, it should actually try to serial print something. I don't know if that means that it'll output it via USB, whichever the first UART that it tries to use is. And it should be 115200 baud. So theoretically, I could, before I even write a single line of code with you guys, I could plug this in and get some kind of an output. It depends on where the initial UART is. UART is a universal auto I don't fucking know. It's a serial port, basically. UART is just a serial port. Universal asynchronous receive and transmit. ERT. I could wire wrap these. Probably should, because then they'll get sort of an innate strain relief in having the jacket right there. Yeah. I guess so. I don't know if I have enough to wrap them on a typical header, though. Just grab any random header that I have sitting around. Which pins do I need? So RXI, TXO, and ground, which should be RX in, TX out. SparkFun thought they were smart and that they were going to help you by having RX in and TX out on their thing instead of just generic RX and TX, but all they've done is added a letter to the end of it that does the same thing as the RX and TX. It's always just guesswork about whether which port is in, which port is out. Okay, so ground is all the way over there. And then we have our RX and TX. I'm using a right angle header because I hate them. I dislike them, so I'm using one. That'll just hold it still so I can get a big blob of solder on the pin. We're doing very basic stuff today. Actually, why am I doing it like that? I want to be able to see the label. Okay, so ground. TX and RX. Soldered. And let's tin these guys. Wherever they're hanging out. I have to do this. It just smacks the burger out of my mouth. Oof. Get a robot arm that just slaps me in the face every now and then with chat controlled bits. $50 bits to pull the stool out from under me. Break my arm. $200 bits to squirt sulfuric acid in Bother's eyes. Seems like, well, that's too long. Hold on. I gotta trim it a little bit. I think we can get this running pretty quickly. It's really hard for me to see this stuff. There we go. Robot arm building another robot arm. Robots building robots. Okay, so theoretically we have a TX and RX and a ground so that it has voltage reference. They're very crappily soldered, but they should work all right. This virtual COM port will come up as like COM 6 or something. And then I've got power coming in through the SWDIO. I need to hook that back up. Oh, maybe that's the reason why I should put screws to the back of this thing. Yeah, I need to put some of the screws back in. Oh, that was a nuclear burp. Wow. Joke's on me for having a croissant as the only food that I've had today. Fatty butter. It's not helping me out. Technically, I mean, if I really wanted to have the serial port, like in the future, there is an extra pin that goes to the USB port that I could sever. There's a resistor that I could remove, and then I'd have that one pin, and maybe I could do like a TX on that. I don't know if it's a UART pin, though. Need to use COM ports for my old vinyl plotter. That's cool. That sounds like a cool thing. Oh yeah, mine is from SparkFun, but you can get all kinds of other ones. The one specifically from SparkFun is because that FTDI chip was like $15 back in the day, which is absurd when you're doing cheap microcontroller projects. So what they did is they made a little interface that had just the FTDI chip, and then when you go to program your microcontrollers, it would plug that virtual serial port in from one programmer. So I've got two of those. One's 5 volts and the other's 3 volts. I think this one's set up for 3 volts, but it doesn't matter if it gets a 5 volt. I don't think it'll blow it up because we're just using it for communications, not for programming. But yeah, you can get all kinds of other COM ports too. Used to make car graphics and signs. That's what a buddy of ours did. He did all this vinyl cutting, and so I was able to make vector art for our rally cars. I did, one was apparently Jack Daniels didn't release it. I think somebody just copied the Jack Daniels bottle and had that as vector stuff. And so I was able to actually make our whole car theme Jack Daniels It was like a cheap knockoff with all the right fonts and stuff. It was great. But we got that all cut out of vinyl, and then we had to put these very complicated sort of frilly graphics back onto the car. It was tough to do. All right, so theoretically, oh, it already broke off. This is why I wanted to wire wrap them, because it would have a little bit of strain relief. Well, let's get SWDIO plugged in first. So the SWDIO pins are here. In this order. Friends ask me to do vectors all the time. My designs also translated well to 3D printing. That's cool. Yeah, we do our fair share of 3D printing here. That's become kind of a mainstay of the channel. Oh, right, I put them into a little header. Oh, that's nice. That's nice, because they're all sorted out for me already. Although I don't know which one's pin 1. N reset is this. So that's, okay, so this goes in this way. Oh, that's so convenient. That's so convenient. Beauty. All right. So now I got to resolder that one wire that broke off. That's the problem with these wire wrap wires, is they're solid core, so they really don't like flexing, especially where you solder them. And also, since I'm soldering to a post, it's all weird. My go-to for 3D printing is Fusion 360, but I'm also sponsored by them, or have a sponsor for them. But it is my usual program. It's, even if I wasn't sponsored, I'd be using it. Let's just butt the soldering iron up against anything. We'll just hit that against everything in here, and I'll just melt everything. And just everything is a big puddle of plastic. I don't think that one's going to hold very well. I probably should have added solder to it, but I think I got it on there enough that we can plug this into USB and see if we can get any kind of a serial print out of this. Do we think it's going to work the first time around without any alteration at all? That's a tough sell. That's kind of a big one there. I know this chip is going to come up just fine, but boy, we're plugging it into two completely different USB things. Okay, so theoretically something might be communicating if the wire isn't too long. Let's just see here. Why do I have a find dialog up? What's going on there? Port. COM4. Oh no, COM8. COM4 is USB. It's Bluetooth. Nope, nothing. All right, so the UART may not be outputting. I think that may be what's going on. So what UART is CAN/USB. It's on it's over here. Yeah. PA 11 and 12 and 10, but that's kind of a weird one. So PA 11, sorry, you guys can't see that. PA 11 and 12 right there. So I need to figure out what UART that is on. So we need to go to the data sheet for that. This one does not share PA 11 and 12. The blue pill. We need the actual. Did I close it? Blue pill Arduino. Let's get, all right, let's just, hold on, let's just close these. I'll just search it again. STM32F103 data sheet. Should probably look for it in PDF, but whatever. Did you really just, I don't need that whole thing. All right, whatever. All right, so down we go till we get to the pinouts. Data sheet, 1, 2, 3. There we go. So PA 11 and 12. We need, this is just the physical pinout. We need the actual We need the actual like stuff it does, not just the identification. Because yeah, here's PE and P whatever 11 and 12. PA 11, 12's up here with PA whatever. Keep going. Ooh, I don't like the momentum scrolling that this mouse does. I can probably turn that off somewhere. Power dissipation, internal clock, total current. I saw something about... Okay, don't care about that. Where are my pin functions? These are all of my min-max tables. Temperature tables. There should be just a big table that tells me what all the pins are. Oh, peripheral current consumption. Oh my God, the things that we know. The things that are known about this chip that I don't need. I don't need these. I mean, if I look up like pinout, maybe I could find a more functional pinout, but whatever. We should get to the table anytime now. Should be a nice big table that tells me what all the pin functions are. Right? Right? Not just physical characteristics for soldering. Oh my God, is it up here? That's overall chip stats. Pinout functions. General information. Timers. There's another data sheet that may have it might be that we have to flip to a different... Oh, there's a temperature sensor. Generated voltage. Oops. That varies linearly with temperature. The conversion range is 2 volt. Internally connected to ADC12 in16. Huh. Cool. What is it actually? Do I actually have this main function after reset default remap? I guess so. PA 10 and 11. PC, PB, PE, PD, PA 10 and 11. USART1 RX, USART1 TX. Okay, so we don't know which one of 10 and 11. Wait. Oh, CTS. CAN RX. USART1 transmit and receive is 9 and 10. Well, I mean, they're going into USB. USB DM. USB DP. 11 and 12. Uh-oh. So USART, RTS, CTS, but we're hooked up in USB, so maybe we don't have the availability of having those TX and RX on the actual bus. What is going on here? Ah, I've got people sending me things. Oh, the right to repair stuff is going on. Okay, so the pins that we have connected to USB that we're able to use are these. And that's what I soldered to. PA 10, 11, and 12. PA 10 goes through an extra resistor to get to the USB minus pin. I don't know what that's about. But if we use USB plus and USB minus as our UART, they're UART compatible, but UART1 goes through pins 9 and 10, which that's an LED. Is P5 flashing right now? Wait a minute. No, P5 is not doing anything. You would think it would be flashing. Well, 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 what do we have here? In the code that I wrote, it's PA9 and PA10, not just 9 and 10, because you can also have PV. Yeah, I'm aware. I'm aware. But according to my reverse engineering of the board, 9 and 10 are what we have our UART1 configured as. I'm probably just going to have to bit bang the serial then. I can't use the internal UART. I was hoping for that because then I could just do what I did on the program. Where is that? Not the stock tester. Close that. I got so many windows open right now. This is secretly, this is a test of how stable this computer is too. Oh yeah, that's my CAN for the seat. CAN test shifter. What I did, the reason these are all up is I put an extra tab on these and have like a list of all the signals, all the CAN bus signals that we'll be playing with later. So this is the code for, no, that's not the right one. This is the code for the MIDI pad. The MIDI pad has a huge number of pins. They're almost all used. So I've got all of these configured as outputs and inputs. And they're labeled PO1, etc., because PO1 is what the label on the button is, P1, etc. It's confusing because the pins on the ST Micro are PA1, but I'm not using that for my variables. Nope, didn't dump the original firmware. This is just a physical reverse engineer of it, and they didn't do anything to like super lock down their chip. With Ben Gizmo, who I have to give all credit for this, they found this code in Platform.io, ST Micro stuff for taking over the system clock. This thing is using the internal system clock, not an extra crystal. And so we took this code from Platform.io and gave it the mul16, which takes it up to 72 megahertz. 72 miles per hour. We're using English units here. So it takes us up to 72 miles per hour for the clock speed. So we're able to load code with the SWDIO programmer into the ST Micro and then make stuff happen. We were able to make the LEDs blink. For my purposes, I need to take a look at whether or not these are actually analog. If these are actually analog inputs, because these button pads have velocity somehow, and they all plug directly into the microcontroller. So what I'd like to do is do an analog read using Arduino because I'm more comfortable with Arduino. Do an analog read of the pin and then print it out to serial. So I had to add some wires here in order to get those USB ports over to a serial thingy-wingy. And so the serial thingy-wingy, oh, did I, wait. Oh, I see, wait a minute. I did this backwards because I'm smart. No wonder. Now we're connected. Supposedly with serial, but I don't think it's going to show up. Yeah, it's not doing anything. Something. Yeah, nothing. If it's a MIDI device, then why not use MIDI? Because we're going to make it into a CAN bus device. This is going to be a CAN bus device, and then all of the devices on the simulator setup on this thing over here will be speaking CAN bus, and then I'm going to have a Raspberry Pi running Node-RED that's going to give HID devices their own CAN bus signals. And so what that means is that I can open up Node-RED, and much like regular old Node-RED, I can have all of my inputs and all of my outputs on an easy to see, like pictorial programming method. And so I'll be able to just make basically string cheese that'll wire all the inputs to the outputs. And hopefully it'll be fast. That's kind of what we're relying on here. And so part of it is taking over this device because I'm not going to use it as a MIDI pad. I'm going to use it as inputs and outputs to the system. So taking over the microcontroller and making it speak CAN bus is natural-ish. We're just not getting anything happening on the UART. Let's just test to see that the setup is okay. And I guess, how do you do this in Arduino? I forget. I forgore. Let's do, okay, what's going on? U and Arduino hardware serial. ESP32, serial begin. Ooh, that's cold air coming in, hold on. That's the, you probably, wait, we can see on thermals. Oh yeah, that's cold. It's the purple void moving in, cooling off that. Wow, look at the walls actually getting colder. All right. You could do that, or you could make it like an analog axis. Yeah, you could do a whole bunch of stuff with the proposed system that I'm thinking of. I mean, I could make it so that if it's above a value, it does something, or if, you know, I don't know, it would light up a light weird. Your own interpretation of what it should do is the limit. You could make it into its own analog axis. I gotta hit this button hard enough or else we can't get out of here. You know, stuff like that. That's the thing, is I want it to be that configurable, and I think Node-RED will help me do that. I want to get this peripheral to speak CAN bus, but in order to get it to speak CAN bus, I need to know internally what its variables are doing and if those buttons are actually analog or not. Because what I tried to do is have it, if it was over a certain threshold, it would display a different number of LEDs. It would basically be a binary number representing what the analog input from the button was. And when I got that running, I pressed the button and like a weird number of LEDs lit up instead of something that looked like a binary number. So I need to actually take a look at this thing from the serial lines. And I don't think that'll be too hard to do. I think we just need to do hardware serial. The chip is certainly fast enough to do it so that we can speak to our TX and RX over here without using, unfortunately, without using the UART, because the UART's on weird pins. And this thing was set up natively to do USB. A while ago, I hacked a Numark NV2, also running an STM32F103. What is up with that? It's like the music, I mean, the F103 is old, right? It's like 10 years old. And I guess all the synth people love it. I guess because it's super duper fast. And if you have it interpreting waveforms, like you need it to be fast, maybe having extra threads helps too. But it's kind of crazy that this is the second STM32F103 that we've run into in a musical device. And then you're confirming even more. With locked firmware, but I have tricks to dump the velocity buttons work using a timed ADC input. Yeah, so I'm wondering about how they're doing it with the, because what I thought, my original theory for how they're doing the velocity on the buttons is that they have a conductive material that your button is shorting out. So you start off with the absolute maximum path of resistance. This is actually inaccurate. It should be, last time I tried to explain this, my computer froze for unrelated reasons, but what it should really be, it should look like this. Hold on. I'm just going to do this super sloppily. It should look like that, because as the edges of this dome connect, your resistive path is through the entire thing here, quickly through there, and then through the entire thing there, right? And so you have the maximum amount of resistance. And the harder you press this button, the less of a path it's going to have to take, and the lower the resistance will be. And then your voltage divider to ground becomes less powerful in light of your low resistance. And so you go from 0 up to 3.3 volts as you press down harder on the buttons. Is my computer still running? We're good? We're here? Everybody's still here? okay, I made it through that explanation without my computer freezing. So I think all that crap that I did with the RAM, I got fat stacks of RAM, chat. Look at all this DDR4 right at my fingertips. We're going to Vegas, baby. Yeah, so anyway, a viewer sent in all this RAM the day before RAM prices went crazy. So I did mem checks and I got the fastest of the RAMs hooked up. So we're so much more stable, and I've got all this wonderful headroom to run all of these stupid programs at once when I'm streaming. I've got a lot of stuff running. It's mostly web browsers, but Robin! Oh, fuck, it's creosote. Okay, so anyway, I think the tap pads are analog, and I tried to have this print out like a sequence of LEDs that would tell me what the value was, but I don't know what the analog read is reading. So I think it'll be easier if we can just put in a serial port. So I'm gonna do this is a bad search. I'm gonna do software serial, hardware serial port communication. I haven't done this in a while, so just bear with me while I Google these things that I don't remember. From the software I send strings, blah, 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 blah. 8N1, that's the end stop stuff. How to use hardware serial, general guidance, maybe? Well, I should just look up on Arduino CC, on the reference, serial, and then somewhere in here, begin, find until, parse, read, etc., write, serial, event. Where do they explain the contents of the... Would begin, let's just see what... Baud and config. That's the parity and stop it. That's not the pins. All right. It's software, not hardware. Serial wire viewer. No. I got this. I just need to remember how to do this. Oh, there's a whole different page for software serial. So I need to do the include. Way the hell up here. I'm not sure if I really need to do that anymore, but software serial. There we go. RxTX and then the logic. So that would be up in the setup. Well, I have a function init serial, but that's not, well, okay, I'll keep that, I guess. So init serial is where? Init serial begin 116200. Software serial, and then USB minus USB plus. And we don't have inverse logic. Used to invert incoming pins. If set, software serial treats a low, 0 volts, or okay, et cetera, et cetera. So then do I just... Yeah, I just begin it. Okay, so let's try that. May need to disable CDC serial from Arduino menu. I don't think so. I'm not sure what that is. That's the problem. I'm teaching Granny to suck eggs, but I've got a lot of time into the F103 chips. I see. Yeah, I conversely, I do not have any time into the F103 chips aside from this program right here. So semicolons after your lines, people. I'm going to bumble through this a little bit and we'll see where we get to with it. So maybe frustrating for people who know how this stuff works. Well, no, I know it's frustrating for people who know how this stuff works because I am sometimes that person. So, and let's just uncheck my variables. USB M and P, right? Oh no, I haven't actually done that yet. Can T and R, but they're on the wrong pins. Hold on, let's double check. Double check, double, triple, double, double check. Oh yeah, this is how insulting this is to the STM32. Sketch uses 10320 bytes, 7% of program storage space. Global variables use 844 bytes, which is 4% of the dynamic memory. I'm not using this thing at all. Yeah, okay, so it says USB support off. Okay, yeah, then it won't claim those pins. All right, what am I looking for? I'm looking for the MS Paint. There it is. And then we're going over here to the USB pins. I call them CAN T and CAN R. That's what they're for the USB, for their implementation of CAN. I'm not sure what the CAN implementation is for the final board. Okay, so CAN T and CAN R. Cant and Canner. Down we go. Where are we? Up a little more? Down a little more. Zero print PO1, A test in binary. I don't know why I want that in binary, actually. Let's get that off of binary. I don't need it in binary. I'm just going to print it as a number. Can, can't, and canner. Four megabytes of hot RAM. Yeah. Okay, 115200 CAN T, CAN R. We might need to flip those, but let's just try it. Now we've got the STM32F1, 32FB programmer. We have upload method is the cube programmer via SWD. And because I put the pins on that little header, it was very easy for me to plug back in. I didn't have to redouble check everything. So theoretically, I hit upload and this thing will go in through the SWDIO and then we'll be able to open up COM8 and maybe it'll talk to us. Maybe it'll work the first time. That's always a possibility, unless I blow up my programmer by accident. So compile, compile, compile. I don't have any LEDs confirming what's going on. I should probably have something that blinks when it initializes. Happens to the best of us. Yes. It's true. I love how people have a square block with two resistors in it, and you put two 0-ohm resistors on it, and if you orient them vertically or horizontally, it'll flip your TX and RX pins as just a precautionary measure. It's like, oh wait, I messed them up. All right, let's put the resistors in the other way, and it'll flip them for you. Bonk, medium density. Start operation achieved successfully. Serial monitor, COM8, 115200. P1? Nope. Nope, that's a big nope. That's a big nope. I don't even see any serial activity though. That should be flashing. So let's attempt a crime. Upload that. This is, again, why you put all of your pin numbers and variables and you put them at the top of your software. Actually, no, this isn't. This is the opposite of that. This would be where having numbers in the code would be fine. Never mind. Really, though, you're supposed to be swapping the pins all the way up top. Dang it. So software serial is not doing anything. Why would you not do anything? Did I short anybody out? Let's test functionality at all. So if we just put in digital read P1 and actually digital write PA1, what was it called again? It was a LED. Oh no, pad 01. Pad 1 and P1 LED. Did a read. And we're going to write oh my God, hitting the insert button is it's like a death sentence. All right. Did it right, PO1 LED, double check that. PO1 LED, and we're gonna write that to, or sorry, we're writing the state of PO1 LED based on the read of pad 01. Pad 01, okay, cool, got all that right. So upload that, and that'll just verify whether or not we're actually functioning. Oh, print to software serial begin. So it should be software serial.begin. Oh, so I need to change them all to software serials? Okay, I'll do that. I'll do that. I just want to make sure that I didn't short out the wires. All right, so my digital read isn't quite doing what I thought it would do. That should be turning off when I press it. But I guess the digital read is a little weird. That or my PA01 pin is wrong. No. That or digital read doesn't work within a digital write. That could also be it. Pad 1 LED based on the state of the digital read of pad 01. Oh, but I don't know if I think I initialized it as an analog, but it should still be able to digital read that. Well, whatever. Point is, let's the LED turned on, so we need to change these into software serial. Then I think all of our problems are in our rear view mirror, and we're finally going to make it big. Yeah, I wasn't trying to do PWN necessarily. I was just going to treat it. I was going to treat it like a digital so that when I push the button, it also lights up. And actually, I should not the LED value so that it's the opposite. But then we wouldn't even see the LED turn on. I see the LED turning on, so I know at least this thing is functioning okay, and we didn't short it out with this thing. But now we know that all of our things are now on software serial, so I'm going to hit upload again, now that we've changed them all to software serial. And we'll see what happens here. This will probably turn off, because I think I have them initialize and write low. Whoa! Expected thingy before thingy. Dun, dun, dun. That means I forgot a semicolon somewhere, right? Huh. Why would you do this to me? Those are good. Those are good. What have you done? Software serial dot begin 11:5200 semicolon. Does that? Well, no, that should have been okay. Unqualified ID before dot token. Oh, it doesn't like software serial begin. So Arduino is sometimes malleable in the way that if you do something like digitally read a pin, it'll just give you that 1 or 0 value instead of like throwing it up in your face. Yeah, I mean, I am using the software serial library. If the serial instance is declared, it did accept software serial, but maybe serial begin, because that was described in, yeah, see, it's my serial, they call it. Software serial. Oh, we need to do this. I see. Okay, so we need to set it up as an object. That I did not do. Canner. Oops, I'm holding down. Can R and can T. And then we don't need that line. What do you... Nope. It's this tiny keyboard, man. Oh, wait, no, hold on, hold on. Wait, sorry, I'm struggling with the keyboard that I'm using. And this actually becomes stuff.begin. And then up here, stuff print and stuff print line. Okay, so now we have the syntax correct. And then just in case, well, it's going to start like mega dumping all this stuff out. So we don't really need to have it tell us that it's done. And then I think that's it. I think that's all we need. We don't need reader available. So software serial.h, give it the TX and the RX. Okay, let's give that a shot. Presumably this will compile. Let us see it work. Go, go, go. Wait, using board Gen F1. Huh. Dang it. Stuff was not declared in the scope. What are you talking about? We go to init serial. Init serial, software serial stuff is equal to software serial can R can T. Stuff.begin. Oh, it needs to be set up in... Okay, so I can't do it there. I need to set this up somewhere else. This needs to be all the way up here. Yeah, yeah. It's just safer to put it all the way up here. So the reason it's organized the way it is because this program is going to balloon and it's going to grow. So I need it to be like a framework so that I can move it to other devices and stuff like that. Oh, hey, there just went in. So serial port? Not quite. We should be so lucky. We should be so lucky. We know no blinking lights. And it doesn't matter if I hit it or not. It shouldn't, yeah, that doesn't change the state of transmission. So let's flip the TX and RX and see if that does anything. Just means I soldered them to the wrong pins. Doo-dee-doo-dee-doo. Come on, let's go. Go, go, go. You know, if I made the program more malleable, I could probably have done all this in software and not had to multiple upload, but whatever. Whatever, whatever. Serial? No serial. We get no serial. Let's see, other possibilities that, am I using the 3-volt board? This one is configured for 5 volts. USB is 5 volts, is it not? That should still be able to communicate. It should be seeing something from the LEDs. Our pins are connected correctly. We have RXI and TXO on there. So really, by all means, we should have a signal going here. Could it be too far for the serial? I don't think it is. We've used this before. This the unfortunate path that the serial takes, the USB takes, is through the wiggly cord, all the way through the Steam controller adapter, and then it goes around back behind the table where it goes to this 7-port hub that connects to this USB-C hub that goes up and around along the back of the table directly into the motherboard of the computer over there. So it is a bit of a circuitous route. It's not very fast. 115200 is well within reason for USB. So could it be some kind of an incompatibility? Maybe the core doesn't quite use the COM port the way that we want it to, like an Arduino. We can test any old serial on an Arduino and see if it does anything. I think I can get one of these and just verify that the serial port works at all. It feels like we're above that though. It feels like I shouldn't need to do that. But we can just get, why is there a mark on this? If there's a mark on it, I don't trust it. That means something might be dead. I don't know why it would end up back in my, well, because I can resolder these. That one needs to be plugged in a weird way. I don't like it. Let's just plug into this one and see if we're communicating over serial at all. Usually I will do something in serial in order to make sure that everything's functioning properly. Like this may have old code on it that's going to communicate to us. No? I guess not. Okay, that didn't work. Yeah, but I don't, you know, if you don't declare it, it's going to go to a default. I want to find one of these that already has something printing on serial. Could be anyone. No, not that one. Oh, wait, yeah, there we go. Started, no button. So, my serial port does work. It is functioning as a serial port, so we can rule that out. This thing was monitoring a button at some point in some previous life. I wanted to make sure that it didn't blow up the FTDI. Oh, at the end when I unplugged it, it said button. I wonder what I was monitoring. That's a weird one. Anywho. So we plug it into the pins that I soldered that presumably go through the USB stuff all the way back to the chip. And we're not getting any serial. And so it might be that the ST micro core doesn't jive with software serial. I don't think I'm doing anything incorrectly here. Software serial. Oh, pin mode. Wait a minute. We didn't declare the pins. We'll just throw that in setup, I guess. Now we need to get that right too. It's RX and then TX. So let's turn this back into R and T. And we'll have to flip those over here. And so now I think we've got all of our bases covered. So let's try that. Always got to go back to the example. Compile, compile, compile. Come on, buddy. Let's see it work. Effortlessly. I don't see blinking lights. No! Okay, let's flip them. R, T, oops. Wait, which one was it? Oh, T, R, T, and R. There. That flips the pins. Yes. Upload. Man, this has been a lot. I haven't dealt with software serial in a little while. Used to know how to do all this stuff pretty effortlessly. It's just gotta go back in and remind yourself of all of the different little proclivities of the system. Medium density, start operation. Start engine has succeeded. I do not see any blinking lights on the TX and RX. Dang it. Come on, man. Just work for me for once. Please. Okay, so it still isn't working. I used to love Rolf. Rolf speaks more like this, though. He's got more of that Jim Henson in him. The Rolf voice. But I guess yeah, hey, I used to love Rolf. He's one of my favorite Muppets. I still love the Muppet Show. The actual show. I used to watch a lot of Muppet Babies too, somehow. Which always had those Star Wars clips in them. Either something is not initializing properly, or we just can't do this for some reason. Stuff.begin 11:5200, which is the way we should be doing it anyway. I'm going to take this out of here and we'll move it up. Just to be all in one place. Yeah, that's exactly the way that they do it. And then you just use it, just like print and print line are all supported. I'm creating new code from an unknown bar. It'll make little loops. Yeah, that's kind of where we are with it. We're making little loops to just make sure that things are properly presented. I sort of started to make this a big skeleton program, but right now it's not doing much. It's pretty much just one little int analog test pad 1 printed out. And yet, somehow, we just don't have it running. Let's see, if I reset power on this, we don't get any kind of an initialized. And there shouldn't be flow control on this thing. You think with software serial, it's not gonna, I mean, this thing is running at like 72 megahertz. We'll try 9600 just so that we cover all of our bases. Damn it! Stupid small keyboard. It's 9600, right? Yeah, I got that right. Fun thing is I don't have to close the serial port to upload code because it's not using the serial port. While one do stuff and it'll lock it into a loop. Oh yeah, we're not locking it into loops here. Although there are some loop lockers down here in this code, and I don't know what that's all about. I guess if it's not okay, it does while one. But having a while one loop in there is dangerous. So, all right, we're not getting anything with 9600 baud. Let me flip the pins again. So we're going to do can R in the receive. If I accidentally soldered in the wires in the right spots, there's a 50-50. That I got it right. Oh, it's still building? Yeah, okay. I think the Arduino forgives a wrong baud rate, doesn't it? Maybe that's other tools do that. Hey! It is analog. Do you see how quickly that happened? Look at that. So it maxes at 900 and it goes down to 0. It starts at something like 4 to 5. So it's like 5 to 9. That's why I did that. PO1 status. How cool is that? I told you guys I knew what I was doing. It only took us 15 tries to get it right. Here, I'm going to put this piece of the offcut of the rail under this thing so that I'm propping it up, because we've got pins going into the back of it. If I really wrench down on it, 980. So I'm going to take that information starting at 200. So that's if we read it into an integer. I think an int is probably fine, but then we map from 0 to 1,000, and it really should be from 200 to 1,000, and we're not making it into an LED count. 0 to 255. That'll probably be about the resolution that we need out of it. But then that'll come in as a negative number when it equals 0. So if a test is less than 200, a test is equal to 0. And then we can print out of the functional software serial port. Are you just reprogramming what the buttons do? What we've done, so how did you plug into the microcontroller? Yeah, so what we've done is we started out with this MIDI button pad, and the USB port fell off. I was using this thing in simulators, not in music. I probably could have kept it in music and used it with like Ableton if I wanted to, especially with the modular synthesizer stuff going together. Actually, what I could do, the cool part about what we're doing right now, is I could make this into an actual MIDI device. I could have these pads actually send MIDI instructions. I didn't really mess around with this. This is just a computer peripheral that I used in simulator setups in order to have cool buttons that made things happen in the real world, or, well, in the game. It was a lot of fun. Broke, sat in a bin. Brother gave me an entire ass car seat, an actual BMW chair, because he upgraded his own interior using the junkyard. Gave me an actual car seat. I had this configured for Star Citizen. It'll do anything now. So it came to, it wasn't a MIDI device. It was a USB device. It uses that USB MIDI thing, but it doesn't speak like real MIDI, like a, like the 3-pin connector or the old, what is it? DIN, what was that called? The 1980s MIDI connector. Yeah, I had it. This was originally labeled and configured to work in Star Citizen. I was using a joystick program in order to make this hit buttons, basically, right? Yeah, 5-pin DIN. So it was DIN. Yeah. Okay, so anyway, here's the thing. You should look for drivers. We are well past that. Listen, we took this thing apart and I characterized all of the hardware that was there. And I mean the physical hardware, like as in what pins connected where, to the letter of the law. I know exactly where all of the LEDs are connected, what pins do what the configuration is supposed to be. Being a musical device, this thing worked very similarly in technology to all the modular synthesizer stuff that we've been doing. So this uses an LM1117, and it uses an STM32 LQFP64. So we were able to hook up SWDIO on these convenient FTDI headers, and I'm able to, using the Arduino core for the STM32 and my knockoff SWD programmer, I am able to reflash the entire microcontroller on this thing to do whatever the hell I want. And so we're just at the precipice of that happening. I suspected that the tap pads worked in this manner, where you have a convex, I don't know which one for that. This is I have it drawn as concave. It might be convex. I don't know what the real one does. Tap pad. When the tap pad barely touches the terminals, you have this resistive material that you have to go through in order to get the signal out. So as you barely touch it, this will be a very weak pull-up because it will be a high resistance and it will match this 2K resistor pulling it down. So initially you get a low value because your resistor here is big. As you press down further, the conductive material shorts out at an earlier place. So it ends up being a smaller resistor. With a smaller pull-up, you have a stronger pull-up, and it gets closer to your input power as read by the analog pin. I knew there was a reason that they did this, because they have them going to individual pins on the microcontroller. And so in doing that, I'm finally able to confirm that that's exactly what's happening. It goes from 0 to 900 in its own internal parlance. The STM32 core that we loaded into this thing is doing its own interpretation of the values of analog that are coming back from that pin, all through this stuff. So now I know what the range of at least this button is supposed to be, and I can cast it as different numbers that make a little bit more sense, or I could just read it as the 0 to 900 if I want. So that was the whole reason we soldered 2 pins on there in order to use software serial within the Arduino so that we could output through the very limited number of pins that are available to us for communication. The USB socket fell off, and so we're using the D- and the D+ lines through all of the existing electronics in order to communicate to software serial, because we don't have specific UART pins on that. We can't say like UART2 or UART4. You can generally specify that with Arduino. So this is like a big deal. We finally got this to the point where I can actually write software to it. Yeah, we used a knockoff SWD-IO programmer, which the pins were labeled FTDI on the board, but we can use SWD-IO, we could use FTDI, we could even use serial input, but we'd have to go to the right place in order to do that, and we just don't have that available. So we basically have achieved a complete takeover of this device. And now it would be up to software in order to make things happen. But if I get this over to a 0 to 255, what I can do is I can, after mapping it, I can analog write to I think I called it P01 LED. Digital write, actually analog write, it should probably be the opposite. How do you not an analog write? You'd have to do 255 minus the number. Digital read. Or no, we don't, we're digital writing that with a value, right? I haven't used analog write in a while. 255 minus, no, stop using insert. Let me just check analog write real quick. Oh no, we want the reference. Now, whatever, get out of here. One sec. The Arduino is this SWD programmer. Yeah, I'm able to use the ST Microelectronics, ST whatever core. They have their own like board for the STM32 series. I guess they decided that they wanted to get in on all of these Arduino users, because you can reach a pretty big audience if you're Arduino compatible. And so ST Micro actually made a core that is compatible with their STM32s, which is what we found in this device, and it wasn't locked down in any way, so we were able to actually plug in my knockoff SWD programmer and get it to load code into this. So I was going to look at what analog is. What are analog? I don't like this. See, I just need this. Pin and then value. P1 LED, right? Yeah, P1 LED. And then the value. And actually, if I really want, I could do this, I could do for int LED count. So instead, we're going to uncomment this. And instead of that digital write, we are going to analog write of I 255 if I is greater than analog. Oh, that was a different piece of logic that I don't need. I don't need this logic in here to ruin everything. And now for the off state, 255 minus 0. Yeah, oh yeah, because we're mapping it up here. That's right. Yeah, okay. So what we're doing is we're mapping it, and then we're setting a floor condition where if it's less than 200, A test is equal to 0. I don't know if it does get there, but it needs to be above 200 to not equal 0. That may be never used. Then we'll print PO1. Oh, yes. Yeah, so what I could do is I could actually take this and do 4. Hold on one second. Let me get through my own logic here. Maybe the printing the value we don't really need. I'll comment that out for now. So what we're going to do is we're going to iterate through an array of the LEDs, and we are going to analog read the value. But that's for the LEDs. That would be for writing it. Reading it, we're going to need a different loop for the analog. So what I'm going to do, take my reads. That's right. Okay. So I'm sorry, I'm just getting through my own thing here. I know you guys are eager to correct me on everything. I don't need that right now. Right now, what I need is the analog count. So it's a separate. Yeah, I have that in scan buttons. I'm just doing this for fun right now. For int I is equal to analog count. And then we're going to map a test, and we'll take the int out of there. So I'll just make that there. For int of I is equal to that thing. And then for this one, it just simply writes it. So how about, let's see, if a test is greater than 0, but that does it for the whole, wait a minute, that does it for the whole loop. Yeah, a test doesn't, okay, hold on. I'm still working. Okay, that's actually, oh God. Okay, I'm getting into it here. Hold on. So that's going to read them. And then I need something that'll iterate through the LEDs per what button it is. They're not the same because I've got these extra LEDs on here. Okay, hold on. Wait a minute. Okay, I need to do the LED count and then have it reference the analog pin to read based on the other table. So we need to go through the 13 values and we need to print them to the LED pins of the same, because pad 1, P1 LED, pad 2, P2 LED. Okay. Sorry, just the logic is knocking around in my brain. Oh, see, thank you for, I don't know if I caught you before you left. Thank you for hanging out. You should use Linux. It's very based. There's only one thing that's keeping me from using Linux, and that's Fusion 360. And that may not stem the tide. I may even just switch over and try to use it in Linux. Okay, sorry. My analog is, or my logic is blowing up my brain right now. We're not going to go through LED count and analog write. We're basically just going to write based on the table. So in that case, we read the pin, and then we analog write not to I, but of LED pins of that. So LED pins of I. 255 minus A test. So analog count, analog read of, A pins of I. So I is equal to A count. I is greater than or equal to 0. I minus minus, because it's a little faster. Analog test is equal to the analog read of the analog pin of I, of ohm. We map it, we limit it, then we analog write it to the matching LED pin in the opposite direction. Easy. Let's try that out. We're not serial printing anything. Serial print if a test is greater than 0. Serial print that'll just be numbers if I do it that way. Why opposite direction? Because the LEDs are active low. They are connected to power, and when they get ground, they light up. So that is, where did I put that? That's over here. So this would be the microcontroller pin here. So instead of always being connected to ground, they're always connected to 3 volts. So we need to make our pin stuff the opposite. So if we write a low, the LED lights up. I'm trying to think of how I can write this so that it's not totally confusing. I want a space after that, actually. Serial print a test. So now it's going to say pin 1 to 13, I guess, if there's a value on it. And it'll only print that if the analog test value is above 0. So I think that'll make a display that we can actually like see what buttons I'm hitting. You can code that with a plus minus X. Yeah, because 255 is the always on, 0 is always off. So we want the opposite. So we subtract the number from 255. And since I'm using the map function there, it shouldn't run away. What happened? Oh, capital P. Capital P. Capitalize your P. Okay, A test. I think we're good. LED pins. Yeah, okay, let's try. Upload. I can't believe all that worked. To be honest, I can't believe we got all that working. Ben Gizmo was the one that really helped out because I didn't know how to do all the clock functions, and it would have taken me a long time to figure out how to do. I might have given up. I was going to replace the entire chip. So supposedly, nah, it doesn't work. my LED logic is not functional. Let's see what happens in serial if it looks like crazy. Oh, okay, everything's broken. I broke it. Is that actually like... It shouldn't be printing PO1. Yeah, see, now it's just not doing anything. Okay. Curses. I is equal to A count greater than 0 minus minus. That puts the number of analog pins in, which is the smaller number. It's 13. So 13, 12, 11, 10, 9, 8, blah, 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 blah. So when it starts, it's at 13. Analog test is analog read, analog pins of I, assuming these are correct. Map it from 200 to 1,000. If it is less than, I'm going to do less than or equal to, because I think if I'm mapping it to 200, then it's going to get stuck at 200. And actually, we don't even know if this works right now. So maybe I should skip these because something is not happening properly in there. And we're just going to analog write whatever the value is, 255 minus. We do need to constrain it from 0 to 255, though. So we'll use constrain a test 0 to 255. So we're not going to get the full functional range of it, but it won't blow up our test. Oh, map returns, not updates, but it didn't jump at me for this. Let's double check. Map. No. Where are you jumping around, Google, you piece of crap? Man. Yeah, y is equal to. Okay. So technically it would be a test is equal to map of that. Constrain doesn't return. Does constrain mess it up too? Still valid code, the logic is still off. If a test is less than or equal to 200, then we set it as 0. So we could probably get rid of the constrain now. If it's at 200, then it's at its lowest value, or it'll be at 0. But map will put it back to 200, so we need to make it a 0 again. So we set it to 0. That means that a test will be above 200 whenever it comes in. Oh, but no, we're mapping it to 0 to 255. That's right. And this should be ahead of that, actually. No, but then it's gonna... Actually, this doesn't matter. If it's below 200, it'll just map it to 0. And then if it gets up to 1,000, it gets up to 255. So actually, I don't need this line at all. I was just worried it would be a little hinky. But let's try that. I think that might fix us. Yeah, it's just gonna, if it's below 200, it'll just hit 0 anyway. I don't know if it'll go negative. I don't know if map will put you into the negatives. I'm not sure. But we could probably see it when I get this thing working. What should happen is when I hit a button, it should start just spitting out the value onto the serial line. Dun, dun, dun. Why are you opening the serial port COM8? You shouldn't be opening it. Why are you opening it? Try uploading again. I don't know if it got confused. We had it spitting out the value of the analog read of the pin, and now I'm making the logic so that it scans all of the analog ports and then writes start operation achieved. Oh, these are all on for some reason. Looks like my LEDs might not be mapped properly. We get anything in the serial monitor? Nope. All right, so it's still a little messed up. Yeah, it's weird when I try to do this stuff. Okay, so that's reading a weird... It's strange that it does that. I've got, not random, but I do have odd values that are lighting up. These should basically be lighting up with however hard you hit this. So it might just be that my serial map is messed up. We're also not printing to COM8 right now. It's not actually doing anything. So if a test, what's going on? What happened there? Code Rush, trading with a party of 4. How you doing, Code Rush? Thanks for the raid. I mean, a test is greater than 0. We'll take that out. So now we're just going to do pin I is equal to that. And it should go through all of the iterations. So we're going to get this completely like just a total barfing of values. You need to flip the zeros to 255. Oh, yeah, because if I'm not... Well, no, it would be 255 minus 0 for the analog, right? 255 minus 255 is 0. 255 minus 0 is 255. So that is what's happening in here. That's flipping it. I mean, I could also flip it here and make it... Actually, wait, no. The analog pin is read properly. It's the LED activation that does the opposite. It needs to be the opposite. So hold on, let's try it. Let's see what this looks like. Let's see what this looks like. I think yeah, I haven't ripped off a pin yet. We're basically taking over this device, Code Rushed, and I'm able to get a value out of this thing for how hard I'm hitting any particular button. I don't know what it's trying to do with the serial port. Like, is it trying to upload it with the serial port now for some reason? USB support if available, none. Low full speed, zeros default. Nano default. Cube programmer, SWDIO. I'm just gonna like unplug and plug in here again. See if that does anything. COM8. Our settings were fine. I is equal to A count, I minus minus. So we're gonna start at the 13th value. Oh, wait a minute. Off by 1 index. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's the number. So we need hold on. It needs to be I minus 1 to index properly. When we write it, LED pins of I minus 1, and then A pins of I minus 1, so that we go to 0 properly. But I'm still running into problems where this thing is trying to file download complete, time-lapse during, blah, 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 running program. Please hold on, start operation, processing apps, serial exception. Error opening serial port COM8. Something weird's going on with the COM port. I guess I'm going to unplug it and upload, and then I'll plug it in and we'll tune in. Compile, compile, upload, upload. Okay, operation achieved. No correction to the LEDs, although they do seem to be lit in a different sequence, but weird. Plugging this back in, and then taking a look. COM8, you doing anything? Nope. Board of COM8 is not available. Yes, it is. Are you a different COM port then? Port. COM8 appears to be available. We might have just had too many shenanigans on COM8. Maybe we should flip the program back to just reading one of these. No, they're all the same scheme because I got this thing to run this loop. So if I take out the analog test and I run the test LEDs, takes a minute. Hold on. Hold on. There we go. So, dude, 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 dude. So, that's all the LEDs, and it's just running through a simple loop, starting with int I is equal to LED count, I is greater than or equal to 0, I minus minus, right low, wait, right high, wait. Keeper of Maps just subbed for 74 months. Oh my God. Still subscribed? Geez, someday I'll remember to fix that. Yeah, you should check out your settings there, man. I think it's auto-updating. It's been doing that for like 70 months. It's crazy. Okay, so we've got, I mean, the logic here works. You know, this is what I've been doing. How's it going? We're taking over the MIDI pad more. I've got more sensical stuff happening. Reverted back to using this old program that just helped me get my pinout correct. So we know that those addresses are good. I don't, you know what? The fact might actually be that the pins here might not be in the right order. Maybe we need to go through these individually and I need to check out which one's doing what. And somehow because the pinout isn't correct, our efforts to read them has been in vain. I assumed that A count was correct, but it is perhaps not. So what I need to do is load up that A test variable individually and then print it out on my own. So let's do that for P2. We know P1 works, and I can just, for the sharts and gargles, we can just throw that in there. So let's get rid of this loop. I'm not actually just going to take it and put it down here and comment it out. Get rid of that loop. So now we're actually not pin I, pin 1, colon, space. And then our print line will be this one. And then int A test analog read of A pins of 0. And actually, I could make that into I and then we could just change the variable, but I think I'm going to leave it like this for now. LED pins of, well, actually, we should probably test that with my logic. So yeah, I minus 1, and then the pin is going to be, we'll keep that logic and just step through it on our own. Colon space. Gotta make it look good. Pin of I, etc. But we're not going to step through I. It's going to be int I is equal to 1. I could load it in from serial. That would be the fancy way to do it. No, Control Z. Hold on. Take all you, Shift tab you all in. And then take all of you, tab you once. Get rid of you. And then get the constraints out of there. We're just going to take a look at what our variables look like. So for I is equal to 1, we take the 0th index of that analog pin. We are going to map it from 0 to 255. Then we are going to not analog write it. We're going to wait on that one. We're just going to look at the pin and we'll try the analog write later. And we'll see what's going on because I think the pins are discombobulated. It sounds like you have automated the value of LEDs. That's why it's cycling through. I have all of my pins in tables so that I can iterate through them more easily. Yeah. And those tables may expand, but those are for all the LEDs and all the analog pins have their own table, and that way I can iterate through and operate on them using numerical 4 counters or whatever. Did you manage to write to the flash? Yeah, we did that last stream, and then over the weekend I put together kind of the skeleton of the program, getting all the pins to where we thought they were. Some of the LED pins were discombobulated, so I had to recombobulate them. But I think some of the analog pins are also discombobulated and will need recombobulating, which is what we're going to do now. Yeah, it's pretty cool, Pseudomaze. This is the program that I wrote over the break, and it literally just blinks the LEDs in order using very simple Arduino parlance just to make sure that I've got all of my LED pins properly configurated. But it's cool that I can take it over like this. I mean, the big breakthrough was Ben Gizmo discovering that in Platform IO, you can get the ST Micro clock parameters configured by just calling void system clock with all of your configuration stuff. And this is apparently why we were able to get this working at all. And so we're able to just throw whatever program we want at it. Pretty cool. I would never have been able to figure this part out. I would have probably put my own microcontroller in there sooner. But what I'm doing now is I'm trying to kind of combobulate all of our values. So I'm setting I is equal to 1 in sort of the most rudimentary type of microcontroller programming, doing things wrong. Upload. I don't know why I'm running into like serial issues. The serial port may be done with our business, which is why I'm trying to put in like the most basic serial print to get that running again. I tried to jump the gun and iterate through all of my pins, and that didn't really work out. Got to take baby steps, man. Redeclaration. Ugh, you. Okay. Let's F and go. It might be that if a test is equal to 0, if the analog read gets a 0 value, it'll be mapping it. Yeah, if this is 0, then that's going to remap it to a negative number. I don't know if that constrains it. Maybe that's what's going on. Let's see if we got a serial print here. What? This is what I'm talking. We're not even getting a serial print on this thing anymore. What happened? Did we break a wire? These wires do break pretty easily, but I don't think we broke a wire. Why isn't you working anymore? Output, stuff begin 9600. And then we should get the print line of initialized. We're not even getting that. So something else is going on. Pseudomaze current project is a relay module that works off 5 volts but drives a 12-volt relay. I'm going to design a boost converter. The MC is way too old and finicky. 3 different chips to play with. Just a MOSFET circuit is all you really need in that. A relay module works off of 5 volts to drive 12-volt relays. Huh. I don't know. It seems like you're going about it in a weird way, but I don't know what the whole project is. So, serial LEDs and analog pins. We're not doing anything else with those 3 programs are actually, yeah, those are initializing, and then we don't have anything doing anything with the analog pins. It's just blank. Just faff. Just faffing. And so in our analog test, oh, I need to enable it. There you go. So we're running analog test, and it's very simple. We just jump through the loop multiple times, and then it's going to come in here and do this. And we know that this stuff works. We've just changed it to I. I is equal to 1. So that should give us pin 1. It runs off USB-C. Oh, that's interesting. Oh, that's weird. You don't want to supply the 12 volts. But the relays are for switching. They're 5-volt relays or 5-volt logic. You can also get USB-C to run 12 volts. Yeah, I think our COM port's messed up. Because by all means, that should be writing the value of pin 1. But it just isn't. So what happened? What happened? Something messed up. Maybe if I close Arduino and open it again. Let's Control S this first. And then run Arduino again. You can sometimes kind of mess up your USB by hammering it a little bit weirdly with these signals. It can kind of mess things up. The USB stack kind of gets done with your BS. A new version? No. Back with COM 8, but nothing's happening. Huh. I don't think my logic is busted because I'm using the same logic as I am with the LEDs. Because you're indexing an array that's not 0 indexed, so you need to -1. And so all the pin modes are being established for these things. And when we told it specifically to write pin 1, the analog pin 1, pad 01, we were able to get it to do stuff. So when we reference a pin of 0, we're getting pad 01. So theoretically, so we're coming in here and we do pin mode, can T, can R, output and input. Then begin stuff at 9600. And then say initialized, it doesn't work. Even though we were able to get it to work before, how do we have it? Or I don't think I had the one line in there. It's literally one extra line. And we should get that print line in there. Try resetting. Oh, there's our initialize. So we're initializing, but we're not stepping through my loop. Initialize serial, initialize LEDs, initialize analog pins. Serial is actually empty. Loop, we run analog test. Analog test, int a test is equal to 0, int I is equal to 1. A test is equal to analog read of a pins I minus 1, which should be pad 01. Print pin I is a test. And that's it. That's all we're doing. Okay. Why would analog test not run? Why would our loop not run? Serial LEDs and A pin. So init serial is nothing. Initialize LED for int I is equal to LED count. I is greater than or equal to 0. I minus minus. And then we initialize all that stuff. We had init A pins running when I ran the LED test. Oh, did I write serial? Yep, that's what it is. I did it again. Good call. That's Colin Gale sitting on my shoulders, correcting everything. The chat IDE never fails upload. No, yeah, the device didn't hang. I used the wrong serial definition. Dumb. Still getting used to it. So it's possible that the previous iteration of the program was hung up because one of my pins is defined wrong. So we need to go through these and just verify that they're connected correctly. And with the serial prints, that makes my job so much easier. Even though this compiling is going to kill me. It would be, if I was better at serial stuff, I would have it so that I would send it a serial thing and it would read from the, you know, whatever number pin that was. But I don't know that stuff very well, so. Yeah, see, it's mapping it to a negative number. And then that gets it close to 0 to 255. So constrain a test from 0 to 255. We'll double check. Is constrain an output or not? I hate these AI results, man. Nope, that'll just do it. Okay. So the constraint in there, we can be a little bit more confident. But we do know that pin 1 is reading from the tables properly. And when I hit PO1, or pad 1, we'll just rename this to pad. We get 0 to 255. So let's move on to pad 2 and upload. Again, this is where I could probably read something from the serial buffer and have it go to that number pin, but oh well. This is going all right, though. This is going well. This is just one of those things. Pad 2. It's still reading. It's the constraint didn't do anything. What? So is a test equal to constrain a test? Maybe that I probably needed to do that. Yeah, so the scheme is you have a convex button or a concave button. I forget which one it is. Where is that? Is that it? No, that's not it. Where is it? It's over here. Okay. You have your tap pad, and I had to reverse where these are connected because it's like this. When you first tap the button, you have to go through all of this material, this stuff, then back through all this material and out. And what that does is that equates to a large resistor. So if you have a big resistor here and a smaller resistor here, it's going to bias lower. When you press down further, this is going to short out sooner and become a smaller resistor. And so with a smaller resistor, you get more 3 volts. So your voltage goes up as you press down harder. And that's what we see here, although our mapping function is still kind of blowing up in our face. The more I press pad 2, the higher the number goes. And that's how they do the velocity. Yep, like piano keys. Only it's done in a PlayStation analog style. All right, so pin 2 is properly assigned. We'll go to pin 3, now that we have our code that actually changes stuff. I'm surprised it didn't yell at me for not having like anything going into constrain. I guess it doesn't really care. Let's go pad 3. Pad 3. Yeah, look at that. Beautiful, beautiful output. And I press down real hard, I can get to 250. That last 5 is 251. 249. Yeah, pretty cool. Values not assigned, errors are off by default in Arduino. I would think it would yell at me for that, but you know. Number 4. Pad number 4. Some of these might be discombobulated still, so this is an appropriate test, even though I should probably make it have like a timer and go pad 1, 2, 3, 4. I could do that. It's just for some reason my loops were blowing up in my face. So, Better to do it this way. Just baby step our way through. So pad 4, confirmed. We only have 13 of these to get through. Beep, 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 beep. Okay. I don't know, the internal timers are going to be all weird. So if I do like a millis operation, I don't think that'll do it. I could set a timer to I++, set like a 30-second timer to increase I. We'll just globalize I. I don't know if I want to do that. How'd I count like 30 seconds in the thing? Now, I'll think about that while we... 4, and then 5 becomes 6. That was pad 4, and I was putting in I is equal to 5. Should that have been pad 5? Yeah, I think that one's discombobulated. This one says pad 6. Yeah, pad 5 isn't doing anything. Oh, pad 6 is doing it. Never mind. So it's the number of the thing. So if I were on pad 5, maybe I just don't remember testing it properly. Stupid. 4 and 5 might be flipped. I gotta check. You could do a for next loop and read all the values into an array. Yeah, that's true. That is true. Pad 5. Okay, pad 5 is pad 5. Never mind. Okay, so far these have been completely accurate. So we're up to pad 7. I mean, like, it's boring when it works. I was thinking I could bit shift millis so that it's counting from 0 to 10. Zero to whatever the value of the thing is. It'd have to be 1 to 13, right? Pad 7. That one's accurate too. So far, so good. Yeah, I think reading them all and just throwing them into variables. But when I tried to have the loops on there, everything was messing up. So there might be a bad pin on some of the later pins. I want to get there, because it was like blowing up all of the loops. Pad number 8. Yeah, it's working. Is analog write not working? LED pins I-1, 255 minus number. If we just write it on the A test, it'll go darker as we get closer to 255. So I'm adding this in for the pins. We know all the pins are good. We're going to go to pin 9 and see if that blows up my whole operation here. It is taking a while. Why are we injecting insulin? What? I didn't need anything. Guess we're just correcting. Pad 9. Okay, pad 9 and P9 is lit up. And as soon as I hit it, it turns off. I don't know if it's able to do analog write properly, because if I barely hit it, it should be dimming instead of just turning off. Like there. Yeah, it seems like it's analog right might not be working. Can you add like a welcome special fart for when someone cool joins chat? Two problems with what you said. No, I'm not going to do that. So, I mean, the LED is just turning off with it, but pad 9, at least we verified. So 10. And then analog right does not appear to be working properly. It's analog right's supposed to be writing a PWM value, which is 0 to 255. And so we've got the LED pin in there, but our A test is running in the opposite direction, obviously. But I think some of the internal timers on the microcontroller are not getting the right stuff. Because it's an ST microelectronics core, it might not have all of the exact features properly. And because we're not using an external clock, we might be running at a speed that isn't exactly catered to properly in the code. And it could be some of the stuff that we put down below, some of those clock overrides could potentially fix it. But for right now, analog right just isn't working. I'll have to get tricky with it and use timers and stuff. Okay, pad 10 is pad 10. Pad IO. 11. So like my original logic was not off of having the different pins. I just don't know why some of them were off. Because we're getting really nice values out of this. All of them have been really stable and just good, you know, good analog reads through and through. I should make a timer iterator, but we don't know the behavior of the timer, as evidenced by our analog right not doing a proper PWM. So 11 is 11, 12 is 12. We got one more button to go. Using Gen 1 in Platformio. Pad 12 is pad 12. All right, last one. If this one's correct, then I can make it into a loop so that it'll only tell us when I'm hitting a button. Kind of neat to be able to leave the serial plugged in the way it is. I guess you could normally do that too. That's true. 13 is 13, so there's no reason why my loops shouldn't have worked. Oh yeah, I don't even need this. For int I is equal to I can't say that word. It's equal to one of those. I is greater than 0. I minus minus. Do all that stuff. And then this, if a test is greater than 0. Do that. Okay, U loop, big loop. A test is equal to 0 for int I is equal to a count, which is 13. I is greater than 0, I minus minus. Analog read from the pin, which is -1. Map, blah, 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 display. Okay, upload. So now when I hit a button, it should give us the read and the pad number. if you add the condition that a test must be greater than 0, but I need to iterate through. What are you talking about? Okay, so nothing appears to happen until I hit pad 7, pad 9, pad 11, 12, 13. If I hit 2 pads, oh my God, it's chaos. 8 and 7. Cool. So, partially functional. And if I make it analog right, the pin, if it's greater than 0, well, actually, it should also write 0, so it should just analog right every single one. And upload that. Now, all of them light up. When I push the button, they just turn off. Do the Fortnite dance, whatever. Whatever. You can't, like, listen, Gen Alpha, you can't choose sequential numbers to be your haha funny number because it's going to come up too often. Yeah, see, now they turn off when I push the button. They should fade when I push the button, but the timing inside of the internal timers of the microcontroller are preventing me from being able to do that. So theoretically, I should be able to take 255 minus the analog test. See, sometimes you just have to baby yourself through your code again in order to get it to do anything proper. We had to just stop, get rid of all this stuff, and then trickle it in until it worked. This is originally what I wanted to do. Yeah, ours was 2 digits higher than that one, but it's not 2 sequential numbers, it skips. So you didn't see it as often. Made it funnier when you did see it. Shakes walking cane. Look at that, now they light up when you push the button. And they should get brighter the more you push it, but unfortunately that's just not the reality. The PWM rate is probably messed up. Actually, that does appear to fade in, doesn't it? It actually does fade. Wait a minute, that's cool. Look at this, look. Yeah, it's a little sensitive, but you can see here it's kind of dim, and there it brightens up. It might just be because I'm crushing more of the button down, to be honest. Because I'm crushing it. And there's like the minimum value for getting anything to happen. Yeah, see, look at that. Oh, look at that. It's doing it. It does it. It fades in. It fades in. That's so cool. Oh, that's cool. Ha ha! Ha ha ha! Ha ha ha! Okay, sorry. Just had to get that out. Cool. This thing is awesome. This has been a lot of fun. And you guys, if you want to get one, this is, oh wait, no, they don't sell them anymore. Nobody has these. They didn't sell enough, so they pulled them all off the market. There's like one in like a Sweetwater store somewhere, the Samsung Graphite MD13. The thing is, you can get devices like this, and I can't speak to whether or not they actually have the ST microelectronics chip in it. I don't know. We lucked out. Like you have to understand how lucky it is that this thing had exactly the right chip for us. You can 3D print them and sell. These are rubber pads. Rubber pads, man. What? Can't 3D print that. It's TPU, I know, but God, that would be such a bitch to do in TPU. Oh my God. You can, should you? Well, so the rest of this is just going to be just brutally programming and figuring out pinouts and stuff. What I need to do is I need to get a matrix button engine running on this thing. This analog test is a complete success. I don't know why it was failing before. It might have just been something in the process of getting this all together. But next I need to do like a matrix test. And then later what I can do is I can read these into buffers. and then determine whether or not I want to actually be pulled in order to output CAN bus, or if I want to output the CAN bus automatically on a change. This thing could make a good drum pad sequencer. I mean, it's meant to be a drum pad, my man. It's what it's supposed to be. It's a drum pad. I don't know about sequencer. I guess that depends on how you hook it up in the computer. I never really figured that out. I guess you could like use Ableton or something, but it's got a lot of cool features that I would like to kind of get going here. In order to read these and the crossfader, I have to enable the mux. There's a mux where if I give it different addresses, it will be able to read the value of those faders and stuff, basically 0 through 7. Yeah, the reason that it looks so good as a drum pad is because it was meant to be a drum pad. It's actually the size of a 10 keyless keyboard too. This is the size of my, what is it, whatever percent this stupid thing is. It is, it fits right behind a keyboard. It's pretty cool. All right, so the rest of what I'm doing, what I'm going to work on tomorrow is just programming my way through the rest of this thing. In CAN bus, eventually I'm going to have this work somewhat similar to the car shifter, where it will be basically two peripherals in one. One of them communicates button presses, and the other one is a bunch of LEDs. So that way I can determine what the behavior of the different buttons are. If I want something to toggle, I can put a toggle in there via node red, and it'll just, use CAN bus to sort of cross-communicate statuses and things. Boy, that was a lot. So with a serial port with analog stuff, I mean, getting directly to the result that we just got, where I'm able to see what all the output values are and have something that responds to the inputs, looks super easy, and the logic can exist in your head, but sometimes it takes all that we just went through in order to achieve it. We need to take little tiny baby steps through the program in order to get things running the way we wanted them to run. So that's where we are with this thing. At least we confirmed that my analog pins are all the correct analog pins. Eventually I'm going to take this and make it 2 devices, but for now, it's cool that we even got this thing to fade. I don't know why the other one didn't look like it was fading, but it starts dim and it starts kind of bright, doesn't it? But it should dim to bright. Yeah, see, that one's working. This one, are these later ones like not? Yeah, these might, maybe it's just because they've worn out. Because it doesn't really seem to be getting brighter. It's these that get brighter. Oh, maybe it's the timers of the different pin banks. Because these are on different pin banks. So that these might not be PWM compatible. That's what it must be. Which is a weird place to put an LED. The idea and the implementation are always 2 worlds apart. Yeah, apparently. Apparently, I had all the right concepts. It's just for some reason, nothing was going right. But we were able to scale the numbers and everything, and it looks like all the pads are functioning just about the same. They did stuff in hardware to make sure to like lock down the voltage levels and stuff. And having a capacitor on the line, I think, helps too. It just kind of slows down the progression of values. Okay, so I'm going to be back on Wednesday. I didn't do the command yet. I did do the thumbnail, but we got a lot of really good progress today. Let me just hop into my admin section real quick here. And then that's over here, and then that's there, and then I take this, and I highlight it, and I copy it, and then I paste it. And then I look to see what day. It's the 19th. Dun, dun, dun. 1-9. I've been doing a lot of work in the background to try to get this thing up off the ground. There's a lot still to do. I got to figure out, why did that didn't send, it just did a new line. There we go. I got to figure out mounting the motor and stuff too. Hopefully we can do a stream where I'm actually doing physical stuff. But for now, it's a lot of microcontrollers. We got some ways to go to get any progress into this sort of whole CAN bus system that I'm putting together. But I'm pretty sure that the capability exists. I think CAN bus can take this. If the Raspberry Pi is fast enough, which I think it will be, we can have it be our signal moderator and it can run the whole show. That'll be really cool to see come together. I don't know if we're going to raid into anybody today, but we got a Code Rush raid, which is pretty cool. That was pretty cool. Rob Oz is going medieval. No one else today, huh? TechSmith is still on. He's probably going to end in 5 minutes. Yeah, so I'm gonna wrap it up here. We'll just pack it up, and I'll catch you guys on Thursday. Sorry, Thursday. I'll catch you guys on Thursday, and we're gonna continue on with this. Hopefully, doing cooler stuff. Maybe we'll get to the point where I'm putting CAN bus onto a thing. I don't know. I haven't decided on a lot of stuff, but I'll catch you guys then. Have a good one. What am I?